Contact has been lost with Opportunity since the 12th of June 2018. This pioneering rover survived an incredible 15 years on Mars's harsh surface, when finally a global dust storm blocked the sunlight from hitting its solar panels for several months. This video is a recap of Opportunity's entire mission, from its first landing to the final dust storm, with all the challenges it overcame and discoveries it made along the way. By the end of this video, I think you'll agree with me that it was a remarkable mission and that it contributed a huge amount to our knowledge of the Red Planet. And it's this knowledge that has paved the way for the missions we are seeing today, like Perseverance. It answered questions like, did Mars once have a more substantial atmosphere? Did it have huge bodies of liquid water on its surface? And was it once more like Earth? And if so, what changed? I'm Alex McColgan and you're watching Astrum, and together we will follow the record-breaking journey Opportunity took on Mars. Let's start right at the beginning. Having launched on a Delta II heavy spacecraft, Opportunity landed on the other side of Mars from its sister rover Spirit, about 3 weeks after Spirit had already landed. Opportunity used a parachute to slow itself on its descent, and fired some rockets just before it landed. The effects of the rocket firing are evident from this lighter patch of ground, as seen by the Mars Global Surveyor. Opportunity first bounced, and then came to land inside a tiny 22-meter crater, now known as Eagle Crater, with the heat shield and parachute ending up a few hundred meters away. NASA scientists were so excited by this that they called the landing a hole-in-one, although they weren't actually aiming for this crater. They didn't even know it existed until they got there, as Opportunity actually landed about 25 kilometers away from its intended target. As Opportunity emerged from its protective shell, the first thing it did was have a look around. Opportunity is equipped with a panoramic camera, which it can use to survey the area. It saw some outcrops only a few centimeters tall, made up of extremely fine dust, each grain far smaller than the grains typically found in Earth's sandstone. Opportunity and Spirit were primarily on Mars for its geology, the end goal being to see if Mars was ever a place that was conducive to life. The way that they did that was by looking at rocks for evidence of water, thus giving scientists an idea of what Mars might have been like millions of years ago, as rocks contain clues about their history. Opportunity explored the outcrop closely over the course of the next few weeks, already discovering evidence that in the past some kind of moving current had made the bedrock dip, although it wasn't clear if it was water that had done this, or volcanic flow, or wind. You can see this in this image, as the thin rock layers are not parallel to each other. On Sol 30, or Opportunity's 30th Martian day on its surface, it got close to the outcrop and used its rock abrasion tool to drill into a section of the rock face. As it did so, it found something known to geologists as vugs, or voids in the rock, the result of crystals having been eroded away. The rock also contained hydroxide ions, meaning water was likely present when the rock formed. Next up for Opportunity was to dig a trench in the soil for further analysis. It did this by digging its front wheels into the soil while the back 4 wheels held it in place. After some shuffling about for 22 minutes, it had made the trench 50 centimeters long and 10 centimeters deep. Under the top layer of soil were some things it had not seen before, including shiny little pebbles and grains so small this microscopic image can't even distinguish between them. Over the course of the next few Martian weeks, having discovered everything it needed to, Opportunity powered out of the crater at an average speed of 1 centimeter per second, and headed towards the next biggest crater in the vicinity, Endurance Crater, which is about 200 meters wide. On its way, it passed by this tiny little crater called Fram. It took a photo, but didn't stop for long. On Sol 84, it reached the edge and had a look inside. Mission planners already knew that Endurance had many layers of rock to be investigated and wanted to have a closer look at them. Opportunity circled around the crater, looking for a good entry point, as getting in wouldn't be a problem, but getting out might. By Sol 127, mission planners decided to drive Opportunity into the crater even if it couldn't get out, as the value of science that could be garnered was too promising to pass up. So, on Sol 131, it carefully edged its way over the ridge of the crater and tried to reverse back to see if it could. Luckily, the angle of the rim was only 18 degrees, well within Opportunity's known safety margin, so the excursion into the crater began in earnest. Opportunity went on to spend 180 sols in the crater. It explored an area called Karatepe, where it saw various layers in the bedrock. It went near to, but not into, some sand dunes, as mission planners didn't want it to get stuck. It saw some wispy clouds similar to Earth's cirrus clouds. And lastly, it went to a cliff face called Burns Cliff, an impressive looking cliff face with various layers separated by broken up rocks and dust. It finally left Endurance on Sol 315. During the time there, the data collected by Opportunity meant that scientists were able to confirm that water didn't just cover this area once, but it was in fact episodic in nature, with floods that would have washed across this landscape before drying up again. At any rate, the water here would have never been that deep. After that substantial discovery, the next stop on its adventure was to investigate its own heat shield. On the way, it came across a rock that was later confirmed to be a meteorite named Heat Shield Rock. It was the first meteorite to be identified on another planet. Opportunity then set a course for Erebus crater. It pressed ahead through a region called the Etch terrain to search for more bedrock. While traversing this area, on Sol 445, Opportunity got stuck in a 30 centimeter sand dune. Things did not look good for the rover. All 4 of its corner wheels were dug into the dune by more than a wheel radius. This dune came to be known as Purgatory Dune. It stayed motionless for just short of 20 Martian days as mission planners frantically tried to figure out how to get it out. They simulated the scenario on Earth and tried various methods before they ordered Opportunity to try anything. On Sol 461, the rover advanced a few centimeters to see if it was doing what their tests had predicted. Over the course of the next 20 Martian days, Opportunity moved a few centimeters, took a photo of the progress, and sent the results back to Mission Control. By Sol 483, Opportunity had successfully escaped the dune and all 6 wheels were on firmer ground. It would have been disappointing if it had travelled for a year on Mars just to get stuck by a 30 centimeter dune. Opportunity studied Purgatory Dune for another 12 Martian days before setting off again on its way to Erebus crater. During its journey, mission controllers uploaded updated software to Opportunity to prevent it from getting stuck again, with software designed by learning what happened from the experience at Purgatory. With this new software update, it was ready to carry on its adventure at Erebus crater. As Opportunity approached Erebus, it came to sections of ground where the bedrock was exposed. Mission controllers named this section the Erebus Highway. As we know, Opportunity's main mission was to search for signs of water on Mars, clues of which can often be found in the planet's rocks. It used its rock abrasion tool to carve circles into the bedrock, and with its microscopic camera, it compared the different structures of the rock to search for evidence of water. You'll notice by here that Opportunity's tracks are in front of the rover. This is still the front camera, but sometimes mission controllers drive Opportunity backwards to even out the wear and tear on the equipment. Erebus is a very old and eroded crater, filled with sand with only a few outcrops showing. You may not have been able to tell it's a crater from the ground perspective because it's so shallow and eroded. It only really becomes visible from the satellite photos. It is about twice as big as Endurance crater at 350 meters in diameter, but Opportunity never actually went inside the crater as there was only more dunes in it. Instead, it stuck to the rim, avoiding larger dunes as it went. Even while carefully maneuvering around these dunes, it hit some soft sand and its wheels sunk in. Luckily, the software that was installed only a few weeks previously noticed that the wheels were slipping and it stopped its drive command. You see, Opportunity is not controlled in real time by a person on Earth with a joystick. There is too much latency for this, between 6 minutes to 40 minutes depending on the proximity of Earth and Mars. So instead, Opportunity is given drive commands. Using these same navigational images you see here, and comparing it with satellite-based imagery, mission controllers command Opportunity to drive forward a certain distance, where it will then take a new photo to show its progress. The software that prevented Opportunity from getting stuck meant that mission controllers could get the rover to reverse out without another several-week delay. During Opportunity's time there, it collaborated with ESA's Mars Express orbiter. The Mars Express images the surface of Mars from orbit to search for different types of materials. Without actually sampling the surface, the data it collects can be hard to interpret. Opportunity, however, can physically interact with the surface material, confirming whether what the Mars Express data showed was correct or not, helping them to refine their future observations. While Opportunity was near Erebus, it was also able to see an incredible transit of the Sun from Mars's closest and biggest moon, Phobos. As it was still making its way around Erebus crater, a big dust storm hit, and Opportunity went dark for a few days. Very interestingly, you can see the difference the dust storm made to the rover as the camera goes from having a clear image to having some dust particles visible. Also, dust settles on the solar panels, meaning it can't generate as much electricity. Very fortunately though, Mars has occasional cleaning events, where wind or even a dust devil will pass over the rover, blowing the dust off the solar panels and camera. Because Mars is so dry, this dust is not at all adhesive, and the dust is so fine, almost as fine as cigarette smoke, that it doesn't take much at all to shift it off. You can notice this cleaning happen over time too if I speed up the footage. Look at this fleck of dirt here, and how it disappears over time. Opportunity doesn't have a means of clearing this dust off by itself, so it has always relied on these cleaning events happening, which, thankfully over the course of the 15-year mission, they did. Sadly, however, during the time at Erebus, Opportunity encountered its first mechanical fault. Its arm was getting stuck all the time, as you can see here. There was a broken wire, although the motor still worked if it was given more power. After careful deliberation, engineers decided the best thing to do would be to only stow the arm away while traveling long distances. Over short distances, it would be kept in a hover stow. This replica is being used to test how it can travel with the arm out in this hover stow position, where the arm is out but it bends back at the elbow towards the rover. They thought it would be better to have the arm stuck while it was out rather than to try and stow it away to find it can never be used again. At least it would be somewhat functional like this. Over the course of the mission, up until this point, it was also encountering a problem with a heater for a motor in the arm that wouldn't turn off. Engineers managed to get away with switching it off with a T-stat switch, meaning a thermometer switch would cut power to the heater if the motor got too hot. But as Martian winter drew near, there would be less sunlight. There wasn't enough power to have the heater on all night. They fixed this by completely disconnecting the batteries at night. This led to another problem, where there would be very big swings in temperature between day and night, meaning the motor would likely wear out faster. At this point in the mission, this motor stalled altogether. Engineers temporarily fixed it by applying more current through the motor, although as a precautionary measure, they stowed the arm outside the rover at night in case the motor permanently stalled. You'll start to notice this in the camera view from now on. By February 2006, or Sol 744, Opportunity visited its last site around Erebus crater, called the Payson Outcrop. This outcrop of fine layers shows a diverse range of primary and secondary sedimentary textures formed billions of years ago. The structures that were observed here were likely caused between a mix of wind and water processes. By Sol 766, Opportunity had left the rim of Erebus and was on its way to the biggest and most impressive crater yet, Victoria. It journeyed through large ripple sand dunes, a type of dune we don't have on Earth. However, Opportunity tried to stick to paths of exposed bedrock, as these are much easier to traverse, and it can stop and investigate along the way. These cobble fields are a bit of a mystery, as we are unsure how they formed like this. On Sol 833, Opportunity almost got stuck again. Previously, mission controllers were thrilled by the meters of progress per day Opportunity had been making towards Victoria, but in this sequence it took 4 days to get out of this dune, which they named Jammerbugt, a Danish term for the Bay of Wailing. Nearly 200 Martian days after it left Erebus, it arrived at Victoria, and what it saw was amazing. High ridge walls, a steep slope in, and beautiful sand dunes in the center. It had already overcome so many obstacles, and this sight was the reward at the end. So, what was so interesting about Victoria Crater? Was it able to provide any valuable information about Mars that Opportunity hadn't picked up anywhere else? Victoria was always going to be an important landmark for Opportunity to reach. Although few thought Opportunity would last the 7-kilometer journey from its initial landing site, at this point Opportunity had lasted more than 10 times longer than its original design lifespan. Victoria is the biggest crater Opportunity had visited yet, being 730 meters wide. It was also the deepest, meaning ancient bedrock outcrops along the walls of the crater were exposed to the surface. Exposed bedrock contains the clues to Mars's past that Opportunity was looking for. Also, as you can see, Victoria made for an impressive sight, especially in contrast to this otherwise flat plain that Opportunity had landed in. In preparation for this new exploration site, mission controllers uploaded new software to the rover, which would enable it to decide whether to send back an image or to extend its arm in preparation to sample an interesting rock outcrop, and even improve the intelligence of the rover to detect obstacles it should avoid and to make its own path around them. Who would have had to have gone through hundreds of images and wait through painful latency delay for commands to be sent to the rover. At its furthest point, the latency between Earth and Mars can be upwards of 40 minutes. This is one of the reasons why it took 3 years to only travel 7 kilometers up until this point. To test this new software update, mission controllers had Opportunity drive towards a patch of rubble, and settings were adjusted to make Opportunity think that this rubble was a no-go zone. In reality, the biggest of these rocks is only 10 centimeters tall, meaning Opportunity could have easily driven over it. But they didn't want to test the systems on something that could actually damage the rover if it went wrong, so they chose these rocks instead. As you can see, the rover adjusted its course around the dangerous area and took this panorama so mission controllers could see how the rover responded to the new program. Opportunity began to circle the outskirts of the crater, imaging it as it went. It came across a few cliffs or capes along the way, imaging them with a very clever technique called a super resolution mosaic. These images have a much higher resolution than the camera on board Opportunity is capable of, and the way they did this was by taking lots of photos of the same thing, and then in post-processing on Earth, they combined the images to provide the resolution you see here. On a side note, this technique is used in many different fields, including microscopy and astronomy. Scientists say that the layers you see in the rocks found in all these cliff faces are due to a geological process called cross-bedding, They believe these layers are ancient sand dune deposits, which is why the lines are inclined upwards and not just horizontally. From these lines, they predict that this used to be a sand dune field not unlike the Sahara Desert on Earth. While this science data was very useful, mission controllers were primarily looking for a passage down to the crater floor, and they thought they found one here by the Valley Without Peril. On closer examination though, it was decided that the slope was too steep. Opportunity investigated a couple of cliffs while it was there, and even came across another meteorite called Santa Catarina, before mission controllers decided to drive the whole way back to the original arrival point at the crater to try and head down by there. This site was chosen because the slope was within the safety limits of the rover, plus the ground was made of flat, exposed bedrock, which meant it wouldn't have much wheel slippage. On the 28th of June 2007, or 1,200 sols into the mission, Opportunity prepared itself for its descent. But just as it perched itself on top of the slope, the biggest dust storm Opportunity had seen yet rolled in, decreasing the brightness of the sun by 96%. That's not quite as bad as it sounds, as the dust also scattered some of the sunlight towards the rover too, meaning it was generating 128 watts on the darkest day compared to its usual 700 watts on a clear day. But this is bad news for a solar-powered rover. That kind of power level isn't enough to keep the rover going. In fact, anything under 150 watts means the batteries begin to run flat. So operations were cut back substantially until the storm was over, and Opportunity was commanded to only communicate back to Earth once every 3 days. If the batteries did run flat, the components on board Opportunity could be damaged due to the intense cold on the planet during the night. Typically, the motors have heaters powered by the batteries during the night to keep the motors warm. If the batteries run flat, there would be nothing to stop there being extreme temperature differences between the night and day. At the equator, anything up to 20 degrees Celsius during the day, and minus 75 degrees Celsius at its coldest at night, which would damage the sensitive components. The reason for this temperature variability is because, although Mars does have an atmosphere, it is 100 times thinner than Earth's, meaning it is not anywhere near as good at retaining the heat it absorbs during the day. Going back to the batteries, if they reached a critical level, Opportunity was also designed to trip a low power fault. This basically disconnects the rover's batteries from all but the most essential systems of the rover, putting it to sleep as it tries to charge its batteries with whatever available sunlight there is. Every sol, the rover would check the battery level to see if it could reconnect the other systems, and if so, it would then re-establish communications with Earth. This low power mode could mean that the rover stays asleep for only a few days, but it could also go on for weeks or even months. Chances are at that point, even if it did switch back on, too many of its components would be broken and it wouldn't be able to function anyway. Back to the dust storm. At the start of July 2007, mission controllers initially thought it would only last a week, but by the 15th of July, the storm had reached its peak. These are true color images showing a time-lapse of the storm, and as you can see, it does get very dark. Thankfully, the severity of the dust storm was not quite enough to trigger the low power fault this time, although it did get worryingly close for a while. Eventually, by the 21st of August, or Sol 1271, the storm had cleared enough so that Opportunity could start to move forward again. Sol 1291 saw Opportunity finally enter the slope of the crater, but like it did before with the previous crater, just after it entered, it backed out again to assess the amount of wheel slippage from the slope. As it happened, wheel slippage did exceed the mission controller's threshold of 40%, so the rover stopped with 2 of its wheels still over the lip of the crater. After 2 days of decision making, mission controllers decided to press ahead regardless, and an extended exploration into the crater began. As Opportunity descended, it took some time to investigate any interesting looking parts of the exposed bedrock. It also took some images of the cliffs on either side of it. I think these images showcase just how steep this slope that Opportunity is sitting on, roughly 20 degrees. Opportunity didn't venture too far into the crater, as only sand dunes were found towards the base. It spent its time examining this light patch of bedrock, taking various pictures and using its rock abrasion tool to investigate the rock structure. It was determined from the data Opportunity collected that this area was likely not ever so hospitable to life. So mission controllers picked the next waypoint on their journey, Endeavour crater. If you thought Victoria was big, look at this mammoth. Endeavour was thought to contain some clays, meaning water was once there, so Opportunity started its journey out of Victoria. At this point, on Sol 1502, Opportunity encountered another fault with its arm. No matter how much power they put into the joint, the arm wouldn't move from its stowed position under the rover. Sol after Sol passed and the joint refused to move, until they determined the time of day the joint had the least electrical resistance, which was just at dawn before the heater for the motor switched off during the day. When that time came, they put as much power as possible into the motor and it worked. Not risking ever stowing it away again, engineers had to determine how to maneuver the rover safely without risking damage to the arm. Opportunity then began its 2-year trek towards the Endeavour crater. This is Endeavour crater, a huge but shallow crater at 22 kilometers across and 300 meters deep. But why Endeavour crater? Due to the distances involved, it would take a long time for Opportunity to get there. So what's so special about this place compared to anything Opportunity had seen before? The most compelling reason, and indeed one of the science goals of Opportunity, was to find evidence of past oceans on Mars. At this point, in 2008, the theory that Mars once held an ocean on its surface was only just starting to get solid evidence thanks to the Spirit and Opportunity rovers. Opportunity at this point had discovered that water once existed on the places it had visited, but these places were no more than shallow floodplains which dried up periodically, not a true ocean. On the other hand, the Mars Reconnaissance Orbiter had spotted what was believed to be clays around Endeavour crater, clays being hydrated minerals which could have only formed from water being on the surface for extended periods there. Could Endeavour have been part of a more permanent ocean? And if there really was a surface ocean, are there clues to indicate that it could have harboured life? Mission controllers had to find out. And so, Opportunity left Victoria crater and began its arduous journey south. The mission team were determined to reach their destination as quickly as possible, while also keeping a lookout for anything of interest along the way. Opportunity made good time across the Meridiani Plains, and by Sol 1818, it had travelled more than 3 kilometers. Nothing noteworthy really happened until Sol 1947, where a large rock was spotted. The mission team decided to investigate, discovering that it was a meteorite which they named Block Island. In fact, large rocks seemed to be the only thing to keep Opportunity busy, later spotting another one called Shelter Island, and a third called Marquette Island. Marquette Island was of particular interest to scientists though, as they believed this rock was part of the ejecta from a large meteor impact, meaning this rock would have come from deep in Mars's crust. Scientists could tell because the grains within the rocks are coarse with a basalt composition. The coarseness indicates it cooled slowly from molten rock, allowing crystals time to grow. Had it formed near the surface, the crystals within it would have been a lot smaller, as it would have cooled a lot quicker. Opportunity was never alone on Mars. It had a sister rover named Spirit, which was exploring the other side of the planet at the time. They both landed on Mars at roughly the same time, and had both far exceeded their original expected lifespan of 90 sols. At this point, they were 1,900 sols into the mission. Although, just like Opportunity up until this point, Spirit had encountered some mechanical failures too. Most notably, one of its front wheels jammed only 700 sols into its mission, meaning it dragged this wheel along as it travelled. In a way, I almost think Spirit was NASA's darling between the two rovers. Spirit often got more media attention for the things it was discovering on the planet. However, it was around the time Opportunity explored those rocks that Spirit, on the other side of the planet, attempted to drive over a sand dune and got its wheel stuck deeply in the sand. Spirit's operators began the long process of attempting to get it unstuck through simulations and testing on Earth-based replicas. Meanwhile, Opportunity carried on its long journey to Endeavour. By Sol 2138, Opportunity finally reached a landmark of note, Concepcion Crater. It is only 10 meters wide, but probably the youngest crater visited yet, evidenced by the exposed rubble and ejecta. Nothing particularly new was found there compared to any of the bedrock Opportunity had examined in the past, which was simply sulfate-rich sandstone containing peppercorn-sized spheres known as blueberries. At least the crater provided a contrast to the vast expanse of rolling sand dunes. 8 months had passed since Spirit got stuck in the dune. The sand that enveloped its wheels was particularly fine, and the process of excavating Spirit was exasperated by its jammed wheel. During this recovery process, another of Spirit's wheels jammed, meaning only 4 of the 6 now worked. The Martian winter approached for Spirit, and it was getting less and less sunlight to power its batteries, until finally a low power fault occurred on the rover and its systems disconnected from the battery. Spirit went silent. Mission controllers attempted for months afterwards to regain contact with the rover, but NASA eventually called an end to Spirit's mission. For the first time since it landed, Opportunity was now alone on Mars. Opportunity's long slog over kilometers of sand dunes to reach Endeavour was becoming taxing for the rover. Perhaps overly anxious not to have a repeat of what happened to Spirit, mission controllers decided to reroute Opportunity's course. A longer route, but hopefully a less arduous one. This route would also take it by what was named Santa Maria Crater. By Sol 2244, Opportunity set a new record for the longest lasting mission on Mars, finally beating Viking 1's mission duration. Opportunity could begin to see the rim of Endeavour, spotting the landmarks of Cape Tribulation, Cape Byron and Cape Dromedary. However, even 100 sols later, it was only halfway to Endeavour from Victoria. It had made good time considering it has a top speed of 5 centimeters per second and often went half of that to be safe, with frequent stops to look out for potentially problematic sand dunes. You'll notice the rover's tracks are ahead of the rover in this time-lapse. This is because there is also a navigational camera on the back of Opportunity, allowing it to drive forwards or in reverse to evenly distribute wear and tear on the motors. Although, another reason right now was to protect Opportunity's extended arm, which, as I mentioned in the last episode, got stuck in this position. On Sol 2449, Opportunity finally arrived at Santa Maria Crater. It's a 90-meter wide crater and was important to mission controllers as there was already evidence here of hydrated sulfate minerals. As I mentioned, hydrated minerals can only form under bodies of water over extended periods of time. So this was an exciting precursor to what they really wanted to investigate around Endeavour, which was still a tantalizing 2-year journey away. Opportunity also stopped here to take a spectacular time-lapse of a Martian sunset or two, with one of the time-lapses showing a transit of Mars's biggest moon Phobos across the Sun. Over 2 years had passed in just this one episode. Opportunity had soldiered on well beyond its expected mission lifetime of 90 sols, and even outlived its sister rover Spirit. It and the mission team had earned a rest at Santa Maria, and they all spent 3 months happily examining rocks and unlocking secrets about the history of Mars. After that, it was onward and upwards for Opportunity towards Spirit Point, a point around the rim of Endeavour, an inspiring commemoration of the mission's loss on the other side of the planet. After spending 3 fairly uneventful months at the Santa Maria crater, Opportunity headed towards the closest hill on the crater rim, known as Cape York. Along the way, it came across a few small craters, some of which were very young, with ejecta from the impact strewn across the place. But Opportunity didn't stay for long. Approaching Endeavour, Opportunity was finally able to see some variation in the landscape after years of simply crossing flat plains of sand dunes. Peaks and capes started to rise up on the horizon as Opportunity approached the crater rim. On Sol 2709, Opportunity finally arrived at Cape York, and specifically a place known as Spirit Point, named after Opportunity's sister rover that had come to the end of its mission on the other side of the planet only a few months previously. Opportunity had travelled over 30 kilometers up until this point, 50 times further than the original planned mission distance. Mission planners decided not to go into the crater, as points of interest were again found around the rim of the crater. Bedrock is exposed to the surface there, which allowed Opportunity to study the oldest rocks it had seen so far on this journey. It was also around these peaks and capes along the rim where the hydrated minerals or clays were detected by the MRO. Perched on top of Spirit Point, Opportunity looked over Endeavour, providing a perspective about just how big this crater is. From the onset, Opportunity began discovering phenomena never before seen on Mars. You may remember from the previous episodes that the soil found around the areas Opportunity had thus far explored contained countless smooth, tiny, round rocks, nicknamed blueberries. Around Endeavour, no blueberries were to be found. Instead, the soil looks much coarser, the rocks sharper and not as rounded. Mission controllers were so impressed by the variation of this area compared to the initial landing site that they said that this section of the mission provided the equivalent of a second landing site for the price of one. The first point of interest Opportunity examined was a large ejecta rock called Tisdale II. It was unlike any other rock so far examined on Mars. It had volcanic characteristics, but contained more zinc and bromine than previously seen. It was determined to be a type of breccia, old rock fragments having been fused together. This was further evidence for water. The impact that threw this bit of ejecta likely released hot underground water that deposited zinc in the rock. Just a short distance from Tisdale II, Opportunity discovered perhaps the most conclusive evidence that water existed on Mars thus far. Can you guess what it is from this picture? Look closely at the bottom of this image, and you'll see a thin white line exposed in this outcrop. A close-up examination of the vein revealed it to be gypsum, the alpha particle X-ray spectrometer on the rover's arm detecting the minerals calcium and sulfur, together making calcium sulfate. They named this vein the Homestake deposit, and it likely formed from water dissolving calcium out of volcanic rocks, which combined with sulfur, and was then deposited as calcium sulfate into an underground fracture that later became exposed at the surface. The impact that threw Tisdale II likely had something to do with this vein as well. If this is the case, it shows that water once flowed through underground fractures on Mars. Later analysis of the data Opportunity collected showed that not only was this likely to be gypsum, but also that the water here would have been much less acidic than it would have been around other locations on the planet, meaning it could have been more conducive to life. Martian winter was soon setting in, meaning shorter days and a lower sun in the sky. For a solar-powered rover that can't adjust the angle of its solar panels, this is not the ideal situation, but for the first time since the mission began, Opportunity had the opportunity to spend the winter on a slope aimed towards the sun, meaning that for this winter it would be confined to an area named Greeley Haven. This area was not only aimed towards the sun, but it was also rocky, meaning Opportunity had a lot it could examine during these few months. This 360-degree panorama shows the tracks of Opportunity as it carefully navigated its way to its winter lodgings. The fact Opportunity had to wait a few months in one spot was actually handy, as the Musbauer spectrometer in the rover's arm uses radiation from cobalt-57 to determine the composition of a sample. However, cobalt-57 has a half-life of only 9 months, which wouldn't have been a problem for a 3-month mission. Opportunity was now 8 years in, and examining the composition of a rock now took weeks, compared to the half hour it would have taken at the beginning of the mission. When it was not examining rocks, it could also use the time to study tiny wobbles in the rotation of Mars to gain insight about the planet's core. It requires weeks of radio tracking the motion of a point on the surface of Mars to measure changes in the spin axis of the planet, something which couldn't be done before as Opportunity was always on the move. The wobbles they were looking for would indicate whether the interior of Mars is still molten or not. Opportunity's weight also meant it could examine the effects of wind on the dunes of Mars from a ground perspective, even at a microscopic level, using the microscopic camera on the rover's arm, checking for slight changes over the months it was stationary. Months had passed, and winter was turning again to summer. On Sol 2947, Opportunity moved again for the first time since it set up camp in Greeley Haven. Luckily, everything that was functioning from before seemed to still be functioning, and Opportunity headed out to the next point of interest. MOR data suggested clays were present in this area, and the mission team were determined to find it. A beckoning outcrop was spotted around Sol 3057, and the microscopic camera revealed something about it that no one was expecting. Much like Opportunity's landing site, these smooth polished blueberry rocks were observed. However, this time they were very much a part of the rock. They were also smaller than what Opportunity had seen before, only a few millimeters in diameter, and not rich in iron like the landing site blueberries. A few of the exposed blueberries observed had been eroded away, revealing their internal structure. Scientists describe these blueberries as crunchy on the outside and softer in the middle. They are different in concentration, they are different in structure, they are different in composition, they are different in distribution. It was quite the mystery. Opportunity had just one more place to visit on its trip around Cape York, and that was the clay patch dubbed Whitewater Lake. On its way there, the Earth and Mars were just going through a phase called solar conjunction, where Mars is behind the Sun, which blocks communications between mission controllers and the rover. This has happened a few times during the course of the mission already, but this time Opportunity gave mission controllers a bit of a scare, as during the communications blackout, Opportunity's onboard computer reset into standby mode. Thankfully, communications were restored, Opportunity booted back up properly, and it carried on to Whitewater Lake. And it was there Opportunity discovered Esperance, the pale rock in the upper center of this image, which is about the size of a human forearm. This was it, the treasure scientists had been looking for. Esperance's composition was found to be higher in aluminium and silica, and lower in calcium and iron, more so than any other rock Opportunity had examined in more than 9 years on Mars. Testing found that this rock had a clay mineral content due to intense alteration by water. Opportunity spent weeks here, making sure the measurements were correct, getting everything it could get done before Martian winter came around again. Sights were set on a place called Solander Point, a sun-facing slope on the next hill 1.5 kilometers further south. Opportunity left Cape York on Sol 3344, having spent 9 Earth years, or 5 Martian years, on Mars's surface. It found the best evidence out of any Mars mission that neutral pH water once existed on Mars. Even though this huge discovery had been made, Opportunity still had a lot ahead of it. mission controllers wanted more evidence of water, and they had their sights set on Solander Point, about 1.5 kilometers further south from Esperance. Martian winter was starting to come around again, which brings with it a reduction in sunlight, from the length of the day to the angle of the sun in the sky. To maximize the generation of power for the little rover, Solander Point was chosen as it's a north-facing slope, meaning as Opportunity explores the area, its solar panels would be angled towards the sun too. It was also believed to contain more evidence of hydrated minerals and exposed layering in the rocks, as spotted by the Mars Reconnaissance Orbiter. 1.5 kilometers doesn't seem so far away, but Opportunity was a slow rover with a top speed of only 2 centimeters a second, and it often traveled half that just to be safe. Scientists didn't want it to crash into rocks or get stuck in sand dunes, so Opportunity would move forward a bit, look around for hazards, and repeat the process. Along the way, the floor underneath Opportunity looked very peculiar. It was primarily large chunks of rocks, smoothed off at the top with sand and dust filling the gaps, almost like a random mosaic. Flat rocky ground is the ideal terrain for Opportunity, so it made good progress on the way to Solander Point. Much like the rest of the mission, blueberries were spotted again, rounded rocks a centimeter or two across. By Sol 3390, Opportunity made it to its winter lodgings and began work on the slope. Even while working here, energy production was very low, hitting only 270 watt-hours per day. Any lower than that, and the rover would have gone into a type of hibernation mode. This was due to the Martian winter, but also because dust had been settling on the rover's solar panels, and there hadn't been a cleaning event for a while. This low power mode meant the work around Solander Point was slow, and it wasn't until Sol 3530 that a cleaning event finally pushed energy production up to 370 watt-hours per day. Cleaning events occur when wind blows extremely fine dust off the panels. Because Mars is so arid, there's nothing adhesive about the dust. So even though Mars's atmosphere is so thin, these dust particles can be easily blown off. A bit like blowing dust off the cover of a book. Dust settles on the rover over time, especially during the massive dust storms that are so big they can be seen from space. Around Sol 3519, Opportunity spent the day examining a surface target. However, embarrassingly, the mesh they used to calculate the distances of objects to the rover was wrong, meaning the instruments on the arm were off by about 5 centimeters. So the images taken were blurry, and the alpha particle X-ray spectrometer couldn't properly detect what it was looking at. This was quickly rectified, and the usual crisp images started coming back to mission control again. A bizarre discovery that was noticed just a few sols later was something known as Pinnacle Island. Opportunity often took days to examine certain patches of ground, but scientists noticed some variation between one photo and another taken a few days later. This rock seems to have appeared out of nowhere. Mission controllers weren't so impressed though, putting it down to a nearby meteorite impact, or even Opportunity bumping the rock into place with one of its wheels. A flyby of the Mars Reconnaissance Orbiter revealed no fresh impact, so that discounted that theory. But mission controllers sent Opportunity on its merry way without investigating the rock further. This caused outrage online, with people suspecting aliens left the rock there as a means of communicating with us on Earth, or that it was a type of fungus that had grown over the 12 days between photos. Some people even went to the lengths of suing NASA over their reluctance to investigate Pinnacle Island further, by imaging it with the microscopic camera on board Opportunity's arm. However, before that really got going, as Opportunity looked back on Pinnacle Island, the mystery was solved. Opportunity had indeed cracked a rock in half, as can be seen by the tracks left in the sand. As far as we are aware, this is the first time something like this has happened on its whole mission, but the chances of it occurring were likely increased as Opportunity's arm was getting less and less mobile through wear and tear. This means that the rover itself now has to turn in order for the arm to reach specific objects, instead of the arm simply reaching across. Another problem that was becoming more and more persistent for Opportunity was the onboard computer randomly resetting. Although Opportunity was always able to turn back on, each reset wasted about a day's worth of science activities. By Sol 3749, these resets caused about half the month to be missed. Mission controllers narrowed the problem down to the onboard flash memory. Flash memory can get temperamental after repeated use, heightening the risk of losing new photos before they can be sent back to Earth, and so the decision was made to reformat the entire drive. This would not only clear the storage, but also identify any bad cells within the drive, so those cells can be avoided in the future. By Sol 3773, the reformatting was completed successfully. Soon thereafter, Opportunity reached Wadowiak Ridge, south of Solander Point. As this was going on, a visitor from the outer edges of the solar system was hurtling towards Mars. Its trajectory would take it just 130,000 kilometers above the planet's surface before it continued on towards the Sun. This visitor was again not an alien, but Comet Siding Spring, a visitor from the Oort cloud. The Oort cloud is found well beyond Neptune and the Kuiper belt, millions of icy rocks in orbits that take millions of years to complete. Because it had such a long time to accelerate towards the Sun from the furthest point in its orbit, the trip from Mars to the closest approach to the Sun only took 6 days. That's 56 kilometers per second. However, because of the close flyby of Mars, it meant that the spacecraft on and around Mars were actually in a better spot to witness Comet Siding Spring than we were on Earth. Mission controllers of the various missions were also a bit nervous about the dust particles that are ejected from the comet traveling at that speed, potentially impacting and damaging spacecraft in orbit around Mars. As such, Hubble, as well as spacecraft around Mars, all began observations of this visitor. Fortunately, mission controllers had already had some practice at this with Comet Ison, another comet that passed by Mars only the year previously. Comet Ison, however, was 80 times further away than Siding Spring would be, too far and too dim for Opportunity to spot. And unfortunately, it was day just as Siding Spring made its closest approach to Mars, but Opportunity was able to snap a couple of photos of it just before dawn. Can you spot it? Here's the annotated version of the same image. As it passed by, none of the spacecraft were damaged by ejected dust particles, but what they did observe from this flyby was completely unexpected. As it passed by, it plunged Mars's weak magnetic field into chaos, albeit temporarily. Unlike Earth, Mars doesn't have a magnetic field generated from within its core. Its magnetic field comes from plasma high up in its atmosphere, which generates a very weak charge. This is enough to deflect solar wind coming from the Sun, but solar storms from CMEs and solar flares push past this induced magnetic field, stripping away atoms from the atmosphere. Comet Siding Spring had a very similar effect on Mars. Comets are also surrounded by a magnetic field, again induced from interactions with solar wind, this time with the comet's atmosphere, or coma. A comet's coma can reach out for millions of kilometers from the comet, meaning that as Siding Spring passed Mars, Mars was enveloped in its coma for a good few hours. This merged both magnetic fields for the duration of the event, with charged particles from both objects interacting strongly with each other, and the atmosphere of Mars actually lost some particles to space as a result. However, apart from the image Opportunity was able to take from the surface, all this went largely unnoticed by the rover. 2015 was quickly approaching, and Opportunity was heading for Marathon Valley, which would take the odometer reading of Opportunity to the distance of a typical marathon. Completing a marathon in 11 years? That's a pretty impressive finishing time. In celebration of this milestone, mission controllers took part in a relay marathon with a replica of Opportunity as they crossed the 42-kilometer or the 26.2 mile mark. But there was more to Marathon Valley than just a waypoint. There were interesting rocks here that mission controllers wanted to investigate. To get down into Marathon Valley, Opportunity had to go down the steepest slope it had faced yet, 32 degrees. such was the steepness of this slope that dust that had built up on the solar panels began to flow off. After successfully descending down the slope, Opportunity first investigated a region known as the Spirit of St. Louis. It's actually a small crater, yet it has some outcrops exposed. Unfortunately, it was around here that the flash memory caused the onboard computer to reset again. Although mission controllers had narrowed down the problem to a specific cell bank on the flash drive, quarantining this section apparently hadn't completely solved the problem. The solution had helped somewhat though. A reset once a month is a lot better than the few times a day they were getting before the reformatting and quarantining. Eventually though, engineers decided to bypass the flash memory altogether and operate the rover in RAM-only mode. The danger there though was that RAM gets wiped if the computer switches off, meaning any scientific data not transmitted back to Earth is at risk of being lost forever should the onboard computer turn off. The northern edge of Marathon Valley was a ridge named Hinner's Point. To the south was a ridge named Knudsen Ridge. In these regions, Opportunity was again looking for clays, past evidence of liquid water oceans on Mars. Mission controllers detected clays on these ridges from orbit with the MRO, which correspond to these reddish areas seen in the enhanced color versions of these photos. Opportunity found these rocks to be brittle and to disintegrate a lot easier than other rocks it had previously observed, as well as having unusual compositions. They were unlike a lot of other rocks in the area. Although data collection was constant here, it was also extremely slow going. The alpha spectrometer on Opportunity's arm was losing its potency, meaning sample analysis that would have taken minutes at the beginning of the mission would now take in days or weeks. This was also combined with Opportunity's temperamental onboard computer, which was really starting to struggle. As a result, it took Opportunity well over a year to get through Marathon Valley. It began to head deeper into Endeavour and was greeted with a spectacular sight. A dust devil was spotted on the crater floor. Spirit, Opportunity's sister rover, had seen dust devils in the past, but they were a lot rarer for Opportunity. It is believed that dust devils passing over the rovers had been responsible for the occasional cleaning events that removed dust off the rover's solar panels. Opportunity's next goal was again found further south, a gully that scientists believe might have been carved out by water. A gully had never been closely examined by a Mars mission in the past, so scientists were excited by what they might find. But getting there was tricky. On its way down the crater rim, it passed through a gap in this ridge named the Lewis and Clark Gap, down Bitterroot Valley to Spirit Mound. On its way down, it took some spectacular panoramas of various ridges overlooking the sand dunes stretching across the crater floor. Upon reaching Spirit Mound, Opportunity had been on Mars for well over 4,500 sols, roughly 12 Earth years. All things considered, Opportunity was in reasonable health and generating a very comfortable 450 watts of power from its solar panels. On its way to the gully, it would stop periodically to perform some science operations like imaging select rocks and measuring argon in the atmosphere. Opportunity finally reached the gully in September 2017. The gully was named Perseverance Valley. Scientists wanted to know whether it was water, ice, or wind that had carved this gully. From the shape of the gully, it certainly looks to have had something flow down it. Opportunity also spotted rocks aligning the channels. Could these have been deposited by water currents? As it turned out, Opportunity wasn't able to find anything conclusive. After several months of examining the area, Opportunity passed through 5,000 sols on Mars. And what better way to celebrate than by taking its first full selfie? You'll notice this image is blurry. That's because it was taken with the fixed focus microscopic imager on its arm. It was only designed for very close targets. In June of 2018, the MRO detected the formation of a dust storm. This isn't unusual. Mars has seen its fair share of dust storms coming and going on a fairly regular basis. Opportunity had even lived through some itself. However, within days of its formation, it was clear that this was going to be a big one. It very quickly spread across the entire planet, and mission controllers began preparations for a period of low power. On the 3rd of June, Opportunity was producing 468 watts of power. By the next day, this had dropped to 345 watts. By the 6th of June, it had plummeted to 133 watts. Dust caught up in this storm filled the atmosphere, obscuring the precious light from the sun to the point where it would have barely even been visible. The worst storm Opportunity had experienced up until this point was in 2007, where the atmospheric opacity, known as a tau value, was at 5.5. This was almost enough for Opportunity to not make it through. This storm, on the other hand, had a tau value of 10.8, almost twice as bad as the previous storm. Although operations were kept very basic, only sending back health reports every morning and evening, by the 12th of June, Opportunity fell into a continuous hibernation mode. The storm dragged on for months, and with each passing day, mission controllers lost more hope that Opportunity would wake up on the other side. 3 months later, the storm finally subsided enough for Opportunity to wake up from its hibernation mode, and efforts were made to re-establish contact with Opportunity. By October, the storm had cleared completely, but no contact had been made with the rover, even after 350 attempts. From November on, mission controllers hoped that if the rover simply had a lot of dust on its panels, that wind would blow a lot of it off. However, 1,000 communication attempts later, all the way through to February, mission controllers gave up hope and declared the mission dead.
MER project off the net.
The 15-year, or 5,352 Sol Mars mission had finally ended. And what a mission it was. Opportunity measured temperatures, atmospheric readings, the rotation of Mars, and more. However, the real prize was the definitive proof that Mars was once a world similar to our own, in that it held stable bodies of liquid water oceans on its surface in the distant past. While we may take that for granted now, when it was first confirmed, it was truly groundbreaking. Shortly before communication was cut off, Opportunity was in the process of sending back one last panorama of its final resting place. Its famous last communication was poetically translated to be, "My battery is low and it's getting dark," and its final image was of the sun obscured by the dust. And there we have it, a recap of the entire Opportunity mission. From its incredible launch on the 5th of May 2018 to the present day as it reached its ultimate powering down, InSight has been an incredible lander. It has peeled back the surface of Mars and listened to the planet's slow heartbeat to gain knowledge unseen by any mission that has gone on before it. It has faced adversity. From day one, Mars fought back with an unending assault to wear it down or catch it off guard. But ultimately, its contributions to our planetary understanding are irrefutable, and it did so with a surprising tool, the planet's quakes. I'm Alex McColgan, and you're watching Astrum. Come with me and discover how InSight did what it did, as well as exactly what it learned. In this supercut, we will explore the mission of InSight as it happened. In the early hours of the morning of the 5th of May 2018, at Vandenberg Air Force Base, Space Launch Complex 3E in California, NASA scientists waited in nervous anticipation at their computers. Outside in the darkness stood an Atlas V rocket, a nearly 60-meter tall, two-stage behemoth capable of lifting nearly 9,000 kilograms into geostationary orbit. Atlas V rockets like this one have launched dozens of times, but it's impossible not to feel a degree of nervousness with each new attempt. Last time this launch was scheduled, It had to be pushed by several months because of a vacuum leak involving the size instruments in its cargo. Over half the missions to Mars to this date had either never left the ground or failed once they arrived on Mars. Even at this stage, there is always a chance of something going wrong. The Atlas V was here to carry InSight, a lander tasked with uncovering Mars's inner structure by studying seismic vibrations. It was not the first lander to attempt this, but it hoped to be the first one to succeed. NASA had sent 2 prior missions to Mars with seismometers, Viking 1 and Viking 2. However, Viking 1's seismometer malfunctioned on landing and could not deploy, and while Viking 2's seismometer did manage to get readings, there was no way of telling whether what it read was a seismic vibration or just the wind. This degree of uncertainty made its readings less reliable. With InSight, NASA would attempt to close this potential source of error. The signal came. Scientists received their last weather reports. Launching a rocket is a risky business. Wind speed, cloud coverage, even solar weather can negatively influence a launch. All must be accounted for. But here, they were given the green light. InSight would be launched within the hour. InSight is a meter-high, 6-meter-long lander sporting 2 large solar panels in a similar design to the Phoenix lander. It comes equipped with multiple instruments for scientific research. It carries a seismometer with a windshield and a robotic arm that will place the sensitive instruments onto the flat surface of the Martian planet. With this, it will detect the vibrations caused by quakes in the Martian mantle or by meteor impacts. Through careful evaluation of the time delay between the various kinds of seismic waves from a single event, it will be possible for scientists to piece together Mars's inner structure with a greater degree of certainty than ever before. But that is not all. Attached is a suite of weather sensing equipment to eliminate any debate as to the source of the vibrations it was detecting, not to mention helping scientists to better understand the climate on Mars. And to give it an even greater understanding of the state of Mars beneath its surface, it carries a mole, a hammer-powered digging tool intended to burrow deep into the Martian soil and take temperature readings. A large drill would not be economical to carry, so this was thought to be a more efficient design. The better we understand the structure of Mars, the more we can learn about its formation, and with it, the formation of other rocky planets in our solar system, like our own. With InSight, we hope to learn if Earth is an anomaly in the solar system. Are many of the other planets like us? What does this say about our formation? And so, at around 4 o'clock in the morning, InSight launched for Mars, causing bone-crushing G-forces. The first stage of the rocket burned for just 253 seconds before its fuel was expended and it detached. Then the second stage, Centaur, kicked in. This burned for another 14 minutes, which was enough time to reach escape velocity. InSight had been built to resist the strain. This first stage was a success, but now it would be time for the long trip through space. It would take another 6.5 months to travel across the 484 million kilometers between Earth and Mars. These months would be quiet, serene, and cold as it drifts through the star-studded vastness of space. InSight's arrival on Mars would be quite the opposite experience. It would be fast, hectic, and hot. InSight entered the atmosphere 125 kilometers up at almost 20,000 kilometers per hour. This generated a lot of heat, roughly 1,500 degrees Celsius. Fortunately, InSight's final stage came with heat shields that were able to absorb this blistering fury. And once the lander slowed down enough, the heat shields popped off and a supersonic parachute deployed, further slowing InSight down. Yes, Mars does have an atmosphere, although it is very thin compared to Earth standards. With the speed InSight was traveling though, this parachute still made a big difference, although it wouldn't be enough by itself to stop the lander from smashing into the planet. But fortunately, InSight had planned for this. Unlike the Mars rovers, which just had giant airbags to bounce on landing, this spacecraft came equipped with its own rockets to land. So InSight's legs sprang into position, ready for landing. Once the parachute slowed it down enough, that too popped off, leaving just the lander itself. It then used its onboard rockets to carefully reach the surface. This whole process took place over the course of 7 minutes. It touched down successfully on the 26th of November 2018. Upon impact with the surface, the rockets kicked up a lot of dust. This is not very good for solar panels, so InSight waited 16 minutes before deploying its solar array to let the dust settle. This impressive unfurling can be seen in this testing environment before it launched. On Mars, these panels generate around 300 to 600 watts under normal conditions. However, dust in the atmosphere does affect power generation, as clouds would on Earth, so this can be different every day. Let's pause now and take a look around. The view that greeted InSight seems bleak and inhospitable, but it would need to get used to it. This rock-strewn, flat, dusty terrain would be its home for at least the next 2 years. Now, InSight was intended to be a 2-year mission. Unlike rovers, it had no tools for moving itself around, but that would not be necessary to fulfill its purpose. Its mission was to sit, listen, and learn. It had a lot of work to do. InSight's mission to Mars had begun. Far above the thin Martian atmosphere, a strange new sight had arrived. 2 little lights twinkled in the night sky. These were not new stars, they were CubeSats called Marco A and B, and they had been following InSight for the last several months. Their mission was to relay real-time information back to Earth about whether the landing had been successful or not, and if the solar cells had deployed. The Marco mission was a technology demonstration mission, so it didn't have any scientific instruments, but rather it carried different technologies to test. These satellites were really small, only the size of a briefcase. They were the first time CubeSats had been sent into deep space, and at the time, no one was sure how well they would do. But so far, they had performed exactly as hoped for. The Marcos began listening out for UHF frequencies from InSight with the antenna on the bottom of the spacecraft, ready to transmit that data back to Earth using this bigger antenna. This big antenna operates like a satellite dish on Earth, except they designed it to be flat so it could be space efficient. Amazingly, these satellites only generate 17 watts of power, yet are able to receive signals from the surface of Mars and transmit millions of kilometers back to Earth. Of course, NASA was not going to put all their eggs in one untested basket. If Marco A and B hadn't worked, InSight would also be able to communicate with some of the other orbiters already around Mars, like the Mars Reconnaissance Orbiter. The only difference is that the Mars Reconnaissance Orbiter can't relay information back in real time. These lights would not be in the sky for long though. After performing their mission, the Marco CubeSats would fly by Mars, unable to slow down enough to enter orbit, and instead go on forever to drift around the Sun. But that is not what InSight sees. InSight does not know the fate of the machines that broadcast its messages. All it knows is that it's time to open its eyes, and maybe call to Mission Control to let them know it had arrived at its destination okay. The first thing InSight did was to send back signals to Earth that it had touched down safely. Along with that signal comes its first famous image. This image is a little messy. As previously mentioned, a lot of dust had been kicked up by the landing, as InSight used descent rockets to slow its fall. Fortunately, InSight's team knew this would happen and attached a transparent lens over InSight's camera to protect it. Later, InSight would remove this lens to take clearer pictures for the rest of the mission. Meanwhile, another camera pointing under the lander revealed the effects of the rockets, which had carved out mini craters under the craft. InSight deployed its 2 circular solar panels, now that it could collect sunlight without dust reducing its efficiency. From then on, it was time to work. InSight quickly began collecting data, even before deploying any of its science instruments. The first thing it recorded was the Martian wind, picking up vibrations sensed by the seismometer still on the lander. This is what it sounds like, although I should note that you will probably either need a subwoofer or headphones to hear this. This has not been sped up. These literally are the vibrations caused by Martian wind going over the solar panels of the lander. The frequency of the vibrations converted to audio. For the benefit of those who can't hear it, here it is pitched up by 2 octaves. InSight can also detect changes in air pressure. Here is the air pressure changing as the wind blows across the lander. This audio has been sped up by a factor of 100 for it to be within human hearing range. What is fascinating is that we don't just have to imagine the wind passing by InSight, as it was also able to capture footage of water ice clouds passing by overhead, visibly showing the direction of the wind. Yes, although Mars is currently a barren wasteland, there is still a tiny amount of water vapor in the atmosphere. Now limbered up, its warm-up science done, InSight was ready for the main event. One of its primary missions on Mars was to listen out for seismic activity, but its seismometer, or SEIS, was still strapped down on InSight's body. It would need to use its robotic arm to lift its SEIS instrument and place it directly onto the Martian soil. But not just anywhere would do. If it was going to settle in for a long 2 years of listening, InSight wanted to choose the best patch of ground. Something flat, with no rocks in the way, so its windshield could lie flush with the ground and provide a perfect sound barrier, providing a means for SEIS to collect its data uninterrupted. And it had a team to help it. Almost immediately after landing, InSight started collecting 3D images of its surrounding area in order to find the perfect spot to place the seismometer. Based on those 3D images, NASA actually recreated this area as accurately as possible back on Earth, even going as far as using the HoloLens augmented reality headset to match up the surface of Mars with the environment they were recreating. Once the perfect site was chosen, the go-ahead was given, and InSight carefully used its robotic arm to place the seismometer on the surface of the planet. From there, it began detecting Mars's faintest vibrations. Then it was time for the mole, and it was here that things started to go wrong. InSight's mole was a piton-shaped self-digging tool designed to dig up to 5 meters down into the Martian soil, taking temperature readings every 10 centimeters, and then extrapolating these readings to estimate the thickness of the Martian crust. A drill that could go this deep would have been too large and unwieldy to bring to Mars. The mole's internal hammer would get around this problem. By hammering itself gently into the soil and having the dust of Mars fall into the hole it was forming to provide it with friction, InSight's mole could in theory reach the 5-meter depth. InSight's mole had been tested in conditions recreated to be as similar to Mars's dusty surface as possible, only on Mars itself it wouldn't dig. Unfortunately, the mole only got 30 centimeters into the dry soil of Mars before getting stuck. Scientists back on Earth scratched their heads. Had it hit a very hard rock, or was the soil simply not providing enough friction? Either way, the mole was now stuck, tilted at an angle before it had even fully exited its housing. Earth-based teams attempted to replicate the problem and look for a safe way to pick up the housing around the mole and maybe use the robotic arm to straighten its course. They had to be careful not to damage it though, as the robotic arm had not been designed for such a task. After many weeks of deliberation, they split the task and started removing the housing to better see what they were doing. Carefully, they coaxed off the outer housing, but it would be some time before further progress could be made. If friction was the problem, scientists were considering trying to use the robotic arm to push down on the soil right next to the mole, hopefully giving it the friction it needed to start digging deeper. It would take careful planning before this method could be attempted though. It was July 2019 when the housing was removed, 8 months after InSight's arrival on the planet. It would be another 3 months before their next move was enacted. Meanwhile though, things weren't all bad, Back in April, InSight had detected its first Martian quake, and this is what it sounded like. Again, the vibrations have been sped up by a factor of 60, as the frequency would not be audible to the human ear. While data like this doesn't need to be converted to audio for scientists to use it, it is useful for us as laypeople so we can better grasp the data. What you will notice though is how sensitive the seismometer is. Even under the windshield, it can pick up vibrations caused by the wind. And even the robotic arm moving can be easily detected, even though it's a few meters away. Detecting seismic activity is not all InSight can do. InSight was acting like a little weather station on Mars, with instruments detecting wind, air pressure, and air temperature. As you can see, even at the equator, Mars is a chilly minus 25 degrees Celsius at its warmest at the moment, bottoming out at minus 100 degrees Celsius. These low temperatures are a threat to any mechanical Martian mission. The fluctuations into freezing cold can cause weathering on scientific equipment that can quickly break them. If it weren't for onboard heaters powered by InSight solar panels, InSight would have already been in big trouble. InSight was also able to detect some gusts of up to 60 km per hour and low air pressures, about 6 millibar compared to Earth's 1 bar. With its first readings taken, but also with its first obstacles encountered, InSight's mission was underway to mixed fanfare. Let us jump forward now in time. Months have ticked by. InSight now approached its first year mark on Mars. Scientists had been considering the problem of InSight's mole. By this point, they began to be more certain that it was not an underground rock that had stopped the mole in its tracks. Scientists had chosen this landing site especially because there were few large rocks in the area, and the mole had been designed in such a way that it should have been able to go around small rocks. The team had taken their time to think through what might be causing the problem, doing their best to create a replica of the situation on Earth using data from InSight's cameras. This isn't a perfect process, as it's impossible to perfectly mimic the lower gravitational conditions of Mars on Earth, even with replicas made from scaled-down, lighter materials. But by October 2019, they had figured out that the likely problem was indeed a lack of friction. When taking photos of the soil around the now exposed mole, they saw that the soil in this spot was different from what they'd been expecting. Although the surface you see here certainly appears loose and dusty, ideal for hammering-based digging, only a few inches deeper there appeared to be a layer of cemented soil known as duricrust. These particles of duricrust stick together more tightly, which means they won't fall into the hole the mole is creating, and thus weren't providing the friction necessary to dig deeper. Scientists hadn't realized that this type of soil was here when they picked the site for landing, as it had been hidden under the surface. But what to do about it? While InSight was equipped with a robotic arm, the top of the mole was not designed to be grabbed by this arm, so they couldn't just move it to another position. And as you can see here, there is a delicate cable designed to relay data from the mole back to InSight, which would be damaged if they just pushed down on the top of the pole with the arm. So, their first plan was to place the arm next to the digging mole, pinning the mole in place. Perhaps this would provide the friction necessary to get it started. Unfortunately, this proved to be not enough. The mole floundered in the dust, making no progress. Next, the team tried to scoop soil into the hole the mole had created. This also proved unsuccessful. More months ticked by, marking the time between each painstaking attempt. Finally, in October 2020, a full year and 8 months after the mole first started to dig, scientists attempted to push the top of the mole with the robotic arm. Although this did cause the mole to successfully bury itself, the hopes that this raised were soon dashed. Even when completely submerged by the ground, the mole would not go any deeper on its own. By the 14th of January 2021, the team gave up on the mole altogether. although they still felt they'd learned valuable information for future missions about the nature of Martian soils. I think they'll have a new respect for duricrust going forward. Fortunately, InSight's other scientific equipment had been working much more effectively during this time. SEIS, the seismometer, was doing a much better job of providing a glimpse into Mars's inner workings. SEIS had been listening to the sounds of Mars for over 2 years by this point, and had detected over 500 different seismic events. Mars does not have tectonic plates like Earth, but it does have volcanic regions that produce quakes from time to time. And quakes produce different types of vibrations, such as P waves and S waves, that travel through the mantle at different rates. By timing the difference between when these waves arrive and listening out for their echoes as the vibrations bounce off the inner layers of Mars, it can be possible to work out Mars's internal structure, as well as learn other fascinating insights. Scientists by this point had learned 3 interesting things from all this data. First, Mars tends to have frequent but small quakes, none more powerful than magnitude 3.7. Scientists were surprised that they detected nothing more powerful given how frequently smaller quakes were happening. Perhaps Mars was more static than was expected, or perhaps they simply hadn't been lucky enough to witness a big one. It was too early to tell for certain. Second, the wind hides quakes. Because SEIS is so sensitive, even with its windshield, it could hear the vibrations caused by the wind, and sometimes this masked the vibrations of small quakes, like static on a radio. During the windier part of Mars's yearly cycle, the number of quakes appeared to go down. This was likely just because SEIS wasn't detecting them. To counter this interference, scientists formulated a plan to bury parts of the seismometer using the robotic arm scoop, as this might reduce the interference from the wind. Finally, and strangely, Mars quakes do not have surface waves. All quakes create waves. 2 of the main types, primary and secondary waves, travel through the mantle. However, normally there are also surface waves that run along the surface of the planet crust. And for some reason, these were not being detected on Mars. Scientists are still not quite sure why, but wonder if this is evidence of extensive fracturing of the upper 10 kilometers of Mars's crust, which might be diffusing the waves. To find out more, it would be necessary to wait and collect more data. However, this is more difficult than it sounds. After 2 years, time was no longer on InSight's side. InSight had reached the end of its expected mission duration, and amazingly was internally still going strong. However, an external problem had arisen: dust. Little by little, fleck by fleck, dust had built up on InSight's 2 solar panels, the 2 solar panels that provided life-preserving power to its onboard heaters. InSight had no machinery to clean its own solar panels. Scientists had hoped that dust devils would blow away this dust in cleaning events, but although some dust devils had been detected, so far, by bad luck, none had passed over InSight. By February 2021, InSight was now only collecting 27% of its potential power intake. Choked of energy-giving sunlight, InSight was beginning to feel its age. Its spirit was willing, but its power reserves were weak. Faced with this, scientists had to navigate a delicate juggling act. They needed to decide where to send InSight's dwindling power reserves: to the arm, to the SEIS reader, the radio, or the vital heaters that kept InSight alive. And by February, Mars was entering its winter period, as well as aphelion, the time in Mars's year when it's furthest away from the sun, and the furthest from its precious source of power. There was only one thing they could decide. They had to settle InSight down to hibernate, using its power mostly to keep its circuitry safe and warm. They hoped that come July, as Mars gets closer to the sun again, InSight could bring its other equipment back online. Hopefully, a cleaning event would come along and the science could continue. Spring arrived. InSight awakened from its hibernation, but as it powered up its scientific systems, it still felt weak. The dust on its solar panels remained and was only getting thicker. InSight was faced with its own mortality, the growing realization that it would never get better or be at its prime again. But in spite of its diminishing power, NASA had been so impressed with InSight's data collection that they extended InSight's mission for another 2 years. InSight rose to the task. With limited time left to it and the end nearing, it threw itself into its task. Up until this point, no quake larger than a 3.7 mag had been detected. If InSight could find something like that, it would be the crowning jewel in the data it had collected. But it wouldn't be easy lasting long enough. At the start of the mission, InSight's panels were capable of producing 5,000 watt-hours each Martian day. Now, they were only producing 500 watt-hours, about enough to power an electric oven for 10 minutes. It was now a race against time to find that last big quake before InSight powered down forever. Back on Earth, its team had its back. Scientists were keen to buy InSight that little more time that it needed to hopefully find that quake. And in early July 2021, they struck upon a seemingly crazy idea. How could you remove dust from solar panels when you only had a large, clunky robotic arm with a scoop? Counterintuitively, add more dust. Specifically, to slowly trickle sand down onto the panels using InSight's scoop while the Martian winds were blowing. Hopefully, by doing this, the wind would alter the trajectory of the sand so it would bounce off the panel's edges, but as it hit the panel, it would knock dust loose, thus removing it in the process. This plan might sound crazy in theory, but incredibly, in practice, it worked. Although it wasn't much, by doing this, InSight gained an additional 30 watt-hours of energy a day. This boost in power provided InSight with an extension of life. InSight made it through the summer of 2021 and into the following year, which turned out to be a game changer. In the final year of InSight's life, past the point where it should have died, it detected its largest quakes. In May 2022, the ground rumbled. Data streamed in. InSight's size sensor detected a Mag 5 quake. Mars's lack of plate tectonics makes this a true giant of a quake for the planet. Just a few months later, InSight's end neared. In November 2022, NASA scientists started to pack down their side of the project. With the data that InSight had collected, they started collating it into a package that will be accessible to researchers around the world. They packed up the Earth-based replicas of InSight and the Martian terrain that they'd been using. They prepared to announce to the world that InSight is in its last couple of weeks of life. But InSight's legacy is not in the metal of its form, sitting forever on the Martian landscape. It is in the things that it learned, the knowledge it brought us. So, for one final time, what did we learn? To begin with, thanks to InSight's data, we now know that Mars does indeed have a crust, a mantle and a core, just like on Earth. However, that crust is much thinner than we expected. It contains 2 to 3 sublayers and descends 20 to 37 kilometers deep, compared to the Earth's, which can have a thickness of 70 kilometers. Its mantle is not as hot as scientists previously believed, and descends a further 1,560 kilometers. Finally, its core is larger than scientists thought, with a radius of 1,830 kilometers. Surprisingly, it is also less dense than expected. This has led scientists to predict that it is not simply made of nickel and iron, like the Earth's core, but that it contains lighter elements like carbon, oxygen, sulfur, and hydrogen. This is a fascinating insight. It explains why the core of Mars is still molten. Much like salt's ability to reduce the freezing point of ice, which is why you see grit thrown on roads in colder weather, these lighter elements reduce the freezing point of Mars's core. It also points to the origin of the planet. These light elements must have been collected into Mars in the very earliest periods of the solar system's history, as by the time Earth was formed, these elements were not around in as great a quantity, explaining why Mars's core has them and ours doesn't. They were also found further out, indicating that Mars must have been brought closer into the Sun's gravity as time progressed, before finding the stable orbit it navigates along today. It confirms that during the early formation of Mars, all the cosmic dust that came together must have heated up and become molten, thus allowing the heavier core metals to easily sink into the planet's center. During this period, or soon after it, Mars began to experience its dynamo effect. Mars today only has a weak magnetic field compared to Earth's. Most of this field is left over as residual traces of magnetism locked into many of Mars's surface rocks. However, back in its early formation 4 billion years ago, Mars's moving metals in its core created a massive dynamo, imbuing these rocks with their magnetism. When the planet cooled, hot materials were not able to move about as quickly as they needed to keep the dynamo going. In time, Mars's dynamo ceased to be. Thanks to the data provided by InSight, scientists will have a much better idea of the timescales involved in this dynamo. This is relevant because when we talk about magnetic fields and dynamos, those can affect what the atmosphere was like. And once we understand that, we'll have a clearer picture of Mars's early habitability. InSight might give us an idea of the time period when life was most likely to form on Mars. InSight has given us an incredible amount of raw data, including a fascinating comprehension of Martian weather patterns. Yet there are still many mysteries. Even though we now know the rough dimensions of Mars's inner structure, InSight's findings have actually disproved some previously existing theories. For instance, under a particularly volcanic region on Mars's surface, known as Tharsis, home of Olympus Mons, a volcano 2.5 times as tall as Mount Everest, there exists a hot spot of magma that feeds the volcanic processes we see in this region. Due to the absence of plate tectonics, it was unclear what was causing this hotspot, which seems to have been present, unmoving, for billions of years of Mars's history. Scientists originally thought that this hotspot was being fed by a lower mantle, but it turns out that Mars does not have a lower mantle. As such, it is back to the drawing board to explain what is causing this phenomenon. Still, these are the sorts of questions and discoveries that drive scientific endeavour. And the discoveries that InSight has given us will inform future missions for decades to come. Scientists will pore over the data, analysing P waves and S waves, attempting to find patterns and meaning in the sounds of Mars's rumbling heartbeat. And who knows how much more we will discover as a result of this successful mission. If more comes in, I will keep you posted. But now that InSight has powered down, as it closed its eyes on the scattered clouds and dusty plains of Mars, I hope that it can rest easy. In spite of its challenges and the ups and downs, it did what it came there to do. It is one of the oldest questions mankind has ever asked. Are we alone in the universe? With the universe as vast as ours, could it really be true that we are the only ones in it? Surely there was some other inhabited world out there. In the 19th century, the question became more specific. How common was life exactly? Could it be common enough to have arisen multiple times in our own solar system? Could it exist, say, on the planet the most similar to our own? Could there be life on Mars? Speculation raged. Sci-fi writers imagined entire alien civilizations on the red planet. Although this has calmed down in the last century, as our first probes and satellites went there and sent back photos of nothing but barren deserts, the question didn't entirely vanish. It simply reframed itself. Could life have once existed on Mars? Not now, but in the ancient past. And for all of our inquiring, to this day it is a question that only has one answer. Maybe. Thanks to probes that have gone on before, we know that liquid water once existed on Mars. And where there is liquid water, there is the possibility for life. This was an incredible discovery when it was made in the 1970s, but it is not proof. It's a question that, if it were proved positive, would forever alter our entire view of the whole universe. Because if life arose twice here, in our solar system, it almost certainly arose elsewhere. But until we find that first fossilized example of life on another planet, we will not know for sure. So NASA said, let's become sure. This is a video about the rover that went to go check. I'm Alex McColgan and you're watching Astrum. Join with me today in this supercut as we delve into the first campaign of the Perseverance rover, the NASA machine tasked with actually collecting samples of fossilized microbial life on Mars to return to us before the decade is out. This could be the rover that finally lays the ancient question of "Are we alone?" to rest. So, how did that first campaign go? Perseverance launched on the 30th of July 2020 on an Atlas V rocket. There was a great launch window around this time where Earth and Mars were aligned just right for a quick rendezvous. In fact, China and the UAE also launched a rover and probe respectively during this same launch window. The cruise took 7 months, and checks on the system showed that Perseverance was in good shape for the atmospheric entry. Landing is the most nerve-wracking part of the whole journey. The extremes in temperatures and speed involved make it very dangerous. NASA have had a lot of practice at it though, and seem to be getting better and better every time. NASA have this cool visualization on their website that I want to show you, because I want you to appreciate that landing a car-sized rover on another planet is no mean feat. First, about 4,000 kilometers from the landing site and traveling over 16,000 kilometers per hour, the cruise stage is detached, and thrusters are used to stop the craft from spinning. At an altitude of 120 kilometers, the craft has sped up to over 19,000 kilometers per hour, but it's here that the Martian atmosphere begins slowing Perseverance down. Due to turbulence in the atmosphere, thrusters are being used to keep the spacecraft steady and to keep this heat shield facing forward, as friction from the atmosphere is heating the shield up to over 1,300 degrees Celsius. Computers on board are autonomously monitoring its position, keeping it aimed at its final landing goal. At 60 kilometers up and 16 kilometers from the target, the atmosphere has slowed Perseverance down to 3,000 kilometers per hour. Now this is where things start to get interesting, as the spacecraft was fitted with a number of video cameras, giving us an unprecedented view of the landing sequence. First, the huge 21-meter parachute was deployed. You may notice the odd pattern in red and white. This is useful for scientists to see the orientation of the parachute, but there's also a hidden code in there. Dare mighty things, the NASA Jet Propulsion Laboratory's motto, written in binary code, with the GPS location of JPL on the outside. At 10 kilometers up, and having slowed to 600 kilometers per hour, the heat shield is released, reducing the weight and exposing Perseverance to the Martian atmosphere for the first time. At around 4 kilometers up, the spacecraft begins imaging the surface to search for a safe place to land. At 2 kilometers up, once it's happy with the landing spot, the upper casing of the spacecraft separates, leaving just Perseverance and the rocket-propelled descent stage. Rockets are necessary as the parachute can't slow the fall anymore. Mars's atmosphere is simply too thin. The rocket stage slows the fall from 300 kilometers an hour to 0, and it hovers 20 meters above the surface. The rover itself is then lowered using cabling, suspended by what is known as the sky crane. And once it's safely on the ground, the rocket stage cuts loose to crash a safe distance away. How amazing is that? And actually being able to really see it is incredible. After a 7-month journey, Perseverance landed on the surface of Mars on the 18th of February 2021. Perseverance is NASA's most ambitious rover yet. To give you a sense of scale, the thing is massive. NASA have basically sent a car to Mars. You may notice though that its looks are heavily based on its famous predecessor, Curiosity. While it may appear almost identical, there have been some major improvements of the design based on what didn't work so well on Curiosity. One noticeable difference is the wheels. Curiosity's wheels have shown some serious wear so far. So Perseverance's wheels are thicker and more durable. They are also less wide, but have a larger diameter. Another improvement is its robotic arm, which is longer and stronger than the one on Curiosity. But the most notable differences are, unsurprisingly, the scientific instruments on board. Because while Curiosity was designed to investigate whether Mars was once a place conducive to life, Perseverance is looking for actual evidence of fossilized life. The first step for it will be to find compelling rocks, and it has an advanced suite of instruments to help it do just that. On the mast is a powerful camera called the SuperCam, which uses a laser to identify the composition of rocks. The camera itself takes a photo to visually identify what the laser is pointing at, so it's not actually this camera that takes the impressive panoramas you'll see later. However, this instrument is really important. It can analyze a rock from several meters away, which means the rover itself doesn't need to move within arm's reach of a rock it wants to identify, allowing it to move on to a new region quicker. The 3D panorama cameras are also located in the mast, and they can zoom, focus, and take video. Once intriguing rocks have been identified with the cameras, Perseverance can move in closer and examine them with the spectrometers in its arm. There are two cameras in the arm, a normal color camera called Watson, and another laser camera which can also take microscopic images called Sherlock. Interestingly, I found these images in the raw files of the cameras, and upon investigation, it turns out they brought this along to test the cameras are focusing well, and that the laser reads the material correctly. There are various materials on the rover, including spacesuit fabric, and some with Sherlock Holmes Easter eggs. For example, this has a maze on it with a tiny Sherlock Holmes image in the middle, and this rock sample has 221B Baker written on it, the famous address in the books. Apparently, one of these rock cross-sections is actually from a suspected Mars meteorite. If true, it would be the first known instance of a rock from Mars doing a full round trip to Earth and back. Another of the instruments is basically a weather station, an instrument that will keep track of the wind, temperature, humidity, pressure, and dust levels. Towards the back of the rover, there is a ground-penetrating radar instrument, which will be used to see the geologic features under the surface. And there is also a rather special experiment module, MOXIE, that will be used to see if oxygen can be extracted from the Martian atmosphere, a crucial necessity for the survival of future human colonies, and surprisingly, even a way to produce rocket fuel. Leaving a planet's gravity naturally takes a lot of fuel. For Mars's lighter gravity, it still requires 30 to 40 metric tons of propellant. It's even harder to do on Earth, and becomes harder still if you have to also carry all the fuel you will need to make the trip home again. However, knowing that we might be able to make most or all of that fuel from liquid oxygen found on the planet makes space travel much more feasible. The last experiment on board relates to Perseverance's primary objective, finding compelling rocks that may host microbial fossils. Once the cameras and spectrometers have identified promising candidates, the arm is equipped with a drill that can either abrade the top layer of a rock to expose the unweathered surface beneath, or if the mission team wants to extract a sample from the rock, the drill can also core out a chunk. The arm will feed the sample through to the body of the rover, where a second arm will move the core to a place where it is sealed, and then a place where it gets stored in one of 20 caches that will be on board. Interestingly, although Perseverance was cleaned as much as possible before launch to avoid contaminating Mars and also these samples, even tiny traces of gases from the rover itself could skew readings. To combat this, there are also some witness tubes that are preloaded with witness materials that can capture molecular and particulate contaminants. Each witness tube will be opened on Mars to capture the ambient environment. They will then be sealed like the normal sample tubes. Comparing the witness tubes with the cached samples will allow scientists to know what the contaminants are and eliminate them. But sadly, Perseverance will not be able to confirm the existence of microbial life by itself. It is actually designed as a forerunner mission. Once Perseverance has filled all the caches, it will place them for another mission to pick up. NASA wants this to be a sample return mission. However, the means of collecting these samples has not been finalized yet. A launch is currently slated for 2026, using a rover to pick up the samples and deliver them back to a rocket, where this rocket will rendezvous with an orbiter, which will make the journey back to Earth with the samples in our hands come 2028. It's a very complicated system, so let's hope the mission teams will really get everything right in the coming years. As the rover turned on its cameras and took in its surroundings for the first time, it found itself staring out across the red, arid, and solitary landscape that we have come to expect from Mars. The terrain around it was mostly flat, albeit interspersed with rocky outcrops. This was intentional. Scientists had deliberately brought Perseverance to a place where its wheels could transport it freely, and where it could find sites of particular scientific interest. To that end, they had chosen Jezero crater. Thanks to the outcroppings of rock that surround the crater, Perseverance would be able to collect rock samples from many different geological periods without needing to do major drilling, helping scientists piece together the geological history of the Jezero crater and to get a better picture of the most likely locations to find life. It would spend some time investigating the sections of Jezero crater near its landing site in what is known as the Crater Floor Campaign, before moving on to the Jezero Delta as part of the Delta Front campaign. You would think that Perseverance would be on the move almost immediately, eager to begin its mission. Thanks to the outcroppings of rock that surround the crater, Perseverance would be able to collect rock samples from many different geological periods, giving it plenty of opportunity to get started on its search. However, you would be wrong. Despite landing on Mars in February, it wasn't until nearly 5 months later that Perseverance made any major effort to leave its landing site and begin its journey. And this was not just because scientists took time carefully testing every single piece of scientific equipment and its software to make sure everything was working smoothly. You see, Perseverance was not alone. In fact, it may surprise you to discover, but you might say it was because Perseverance was pregnant. Cradled in Perseverance's undercarriage, hidden by a dust shield from the Martian winds and atmosphere, Perseverance had brought with it a second, smaller passenger to Mars. And much of the initial few months of Perseverance's time was spent helping bring that second passenger into the world. This second passenger was to be Perseverance's companion for the journey ahead, as well as an interesting tech demo. This smaller robot was not a rover. Its name was Ingenuity, and it was the first ever attempt at a helicopter on Mars. After performing several tests on Perseverance's own software and hardware, scientists turned their attention to this smaller 1.8 kilogram drone. The atmosphere on Mars is about 100 times thinner than Earth's, making it uncertain whether a helicopter's spinning blades would even work there. It would be difficult to displace enough air to create lift. Ingenuity was incredibly lightweight to compensate for this, and its rotor could spin at revs of over 2,000 RPM. Its only scientific equipment was a camera, but this would be invaluable in helping Perseverance find the best routes through the potentially tricky Martian terrain. So, on the 21st of March, nearly a month after landing, the birthing began. Perseverance started by removing its dust shield, allowing Ingenuity to taste the Martian air. Mechanical birthing is a slow process, however, with scientists constantly checking every single piece of data to make sure everything is functioning as it should. It wasn't until the 3rd of April that Perseverance finally placed Ingenuity on the hard Martian soil and allowed it to experience its first cold night on Mars. Temperatures on Mars reach lows of minus 100 degrees Celsius, so outside of the protective heaters of Perseverance, it's no small thing that Ingenuity survived the night with no problems. But scientists were delighted that this part of the mission went smoothly. During this stage of Perseverance's mission, it looked on like a proud parent as Ingenuity began to take its first wobbling steps, although just like a parent, Perseverance couldn't resist taking a selfie or two to show off to its friends on Earth. Ingenuity's first flights did not go completely without a hitch. After taking time to test its rotors at varying speeds, Ingenuity did run into some software issues that worried the engineers who'd worked on it. However, by the 19th of April, Perseverance was able to record as the solar-powered drone attempted the first ever controlled flight on another planet. The flight was done autonomously, as the time it would take for a signal to travel from Earth to Mars would create too much lag to try and fly remotely. And there were a lot of unknowns. Mars has a lighter gravity compared to us, as well as having thinner air, which meant that testing the rotor on Earth didn't necessarily mean it would work on Mars. It's hard to properly replicate lower gravity on Earth, for example. But fortunately, and with incredible smoothness, Ingenuity rose to an altitude of 3 meters and remained hovering there for 39.1 seconds, just as planned. Scientists were very excited when the tech demo that had been proposed just 6 years earlier had proved itself a success. Ingenuity was not expected to last long on Mars, but it kept going and going, flying further and higher than every previous attempt. It didn't crash, didn't break, and actually has become a useful scout for Perseverance, to find good routes for the rover to take, or to search for points of interest too small for satellites to detect. Ingenuity went from a disposable tech demo at the beginning of the mission to a valuable aid and accomplice for the Perseverance rover. What about Perseverance? The Martian rover was not completely idle during this time. Perseverance was able to test out a lot of its own gear while it waited for Ingenuity. Perseverance was equipped with a microphone, and scientists hoped to get the first ever audio sample from the Martian surface. Soon after landing on Mars, Perseverance was able to do just that, giving us our first idea of what the wind on Mars sounds like. It certainly adds to the desolate feel of the landscape. Perseverance also spent time driving short distances to test its motors, took panoramas of the surrounding landscape, and even successfully extracted oxygen from carbon dioxide out of the red planet's atmosphere using its MOXIE instrument. MOXIE, which stands for the Mars Oxygen In Situ Resource Utilization Experiment, managed to produce about 10 grams of oxygen in 1 hour. Which is not that much, but to be fair, MOXIE is only a prototype about the size of a car battery. It would need to be 100 times larger if we're to actually use it on the red planet to support human interests. However, just knowing that it works is an exciting step forward. But as fascinating as all these things are, there was one thing that Perseverance still needed to do. It had come here to discover one very important thing. Was there ever life on Mars? And so, during this period of downtime, scientists were busily plotting the best possible route for Perseverance to take. Although Perseverance's landing was one of the most accurate Mars landings NASA had achieved so far, it was still many days' travel from some of the 40-meter tall outcroppings of a rock at the edge of a crater known as South Sitar that scientists wanted to investigate. And between South Sitar and Perseverance's landing site, there lay a dangerous dune field filled with loose sand, impossible for the rover to cross without risking getting stuck forever, which would spell an end to the mission. Scientists would need to decide the best possible route around the dunes. Was it better to travel anti-clockwise around the crater, which would get Perseverance to the outcroppings faster? Or would it be better to travel clockwise, which would take longer, but would allow the rover to stop by more interesting rocks along the way? In the end, as is often the case in space exploration, it came down to efficiency. Scientists chose the second option, to allow it to do as much science as possible in as many areas as possible in the limited time the rover had available to it. Perseverance was finally given the go-ahead. And so, on the 1st of June, almost 5 months after arriving on the red planet, Perseverance's wheels trundled into life, and the rover finally left the safety of its landing site and set out on its primary mission, to collect core rock samples from locations life could potentially have flourished, for ultimate return for analysis to Earth. The search for alien life could now begin in earnest, with Ingenuity following along to keep Perseverance company, of course. Millions of years ago, a massive object had crashed into the surface of Mars. The resulting crater was hundreds of meters deep and 40 kilometers in diameter, and due to the different geological conditions that existed back then, it soon began to fill up with water. In time, this crater became a massive lake and earned the name Jezero, which, somewhat unimaginatively, literally means lake in some of the Slavic languages. Massive rivers began to run into the Jezero crater, carving valleys through the terrain and depositing all the resulting silt over huge deltas. This is why Jezero was selected as the site for Perseverance's mission. If life worked the same way here as it does on Earth, this location could be rife with possibilities for the emergence and propagation of life. As Mars is now a barren wasteland, the kinds of things Perseverance is looking for would not be immediately obvious. Any life that swam in Yezero's lake would have lived, died, and fallen to the lake bed, where accumulated silt from the river would have buried it in hard rock. Perseverance would need to make good use of all the tools at its disposal: its drill-mounted arm, its ultraviolet spectrometer Sherlock, and its X-ray fluorescent spectrometer Pixel to find this evidence. However, it is important to choose targets carefully. Perseverance has limited resources available to it. It only has just over 30 sample tubes for storing rock cores for the return journey home. Tempting as it might be to just grab a sample from right where it landed, Perseverance needed to only collect samples from the locations most likely to provide evidence of signs of life, or offer particular insight into the formation and age of Jezero crater to pinpoint better possible locations for later. As such, Perseverance did not start drilling immediately, but instead began traveling south from its landing location at Octavia E. Butler Landing, named after the science fiction author, to the area known as Cratered Floor Fractured Rough. Although this location was less than a mile away from Perseverance's landing site, Perseverance would not arrive at this new location for nearly 60 days. This is because the unfamiliar, rocky surface of Mars is strewn with obstacles for a rover. You'll notice the rocks that are scattered over the Martian surface. Perseverance would need to pick its path carefully around these, as the rover's 52.5 centimeter diameter wheels can only drive over objects that are so large. Soft terrain poses just as many dangers. The previous Martian rover Spirit came to an unfortunate end after getting stuck in a sand dune. So choosing its path is a balancing act, not too hard and rocky, but also not too soft. And in the past, these decisions would have been made on Earth with a 20-minute average signal delay. No wonder the previous rovers had travelled so slowly. However, Perseverance had gotten an upgrade compared to Spirit and Opportunity. Advanced AI software called AutoNav on the Perseverance rover allows it to map out its surrounding environment and choose for itself the best path through it. Although there is still some oversight from Earth, this greater degree of independence, which Perseverance can do on the fly while driving, allows the Perseverance rover to travel much faster than the rovers before it, allowing for more science to get done. And speaking of science, on the 20th of July, Perseverance successfully managed to navigate its way to Cratered Floor Fractured Rough. Taking things slowly, scientists picked out a rock to first test Perseverance's abrading drill systems. The abrade attempt took place on a paving stone nicknamed Guillaume, and it was a simple success. The drill cut away the top and gave scientists insight into the kind of stones that Perseverance was driving on. By examining grain sizes, chemical composition, and other details, scientists would gain insights into the type of rocks these were, either sedimentary, the kind likely to contain fossilized remains and other artifacts, or igneous rock formed from magma. What they saw heartened them, and on the 6th of August, scientists picked out another target rock, nicknamed Rubion, to take their first actual core sample. Due to the time zones involved, it was only 2 AM Pacific Daylight Time when over 90 engineers and scientists gathered online to witness the fruits of their years of labor. Perseverance cored successfully down to the 7 centimeter depth it had been programmed to reach. It photographed the hole afterwards, and everything seemed to be going fine. Over the next 6 hours, Perseverance painstakingly took the core, placed it in one of its tubes, and moved it to its adaptive cache-in assembly, the place where core samples are processed. Due to the nature of the mission, it's vitally important that no contaminants be allowed to enter the tube, or else it might invalidate the entire process. Finally, Perseverance transferred the now sealed tube to its storage unit. Scientists were elated at this perfect first-time success. But then more data came through, and scientists realized that there was a problem. The sealed tube was empty. Confusion filled them. Where had the sample gone? Due to the limits of technology, scientists could not record on camera every movement of Perseverance. It only has so many cameras. So they had to rely on Perseverance to follow the orders they sent it. But here it seemed that Perseverance had followed its orders, and yet the weight sensors in the storage unit informed them that the tube was missing any additional weight. The core was gone. Perseverance drove backwards and looked between its tracks, but there was no sign of a dropped core. In time, scientists arrived at a bittersweet conclusion. Perseverance had not malfunctioned or done anything wrong. It was the rock itself that was to blame. In the act of drilling, the unique nature of the Rubion rock meant that it was so crumbly that when Perseverance had gone to pick the core sample up, it had completely turned to dust. Perseverance could not collect it in that state. Scientists had tested Perseverance's coring on 100 different types of rock on Earth, and it had never encountered a problem like this before. Every other rock had been cored successfully. So while this was good, because it meant that Perseverance was not broken, it cast a shadow over the rest of the mission. Would all the rocks Perseverance encounters be failures like this? However, NASA was not about to give up without trying. They reasoned that the rocks in this area were likely particularly weathered, and other rocks on Mars might hold themselves together better. It was with renewed determination that Perseverance had another go. Casting its camera around, Perseverance spotted some rocks 150 meters away that were as different from the crumbly paving stones as possible. Scientists nicknamed these new rocks Citadel, which is French for castle, possibly hoping for something a bit more fortified this time. As these rocks were sticking up from the landscape, it seemed reasonable that they were made from sturdier stuff than the flat paving stones. If they resisted erosion, they might do a better job of holding themselves together under a drill. Perseverance trundled over to the ridge and primed itself for another attempt. On the 1st of September, NASA once again held its breath as Perseverance attempted its second core attempt. You really get a sense of how painstaking this process is, given the month-long gap between each attempt. Everything on Earth has to be checked and double-checked, every scrap of data analyzed for the perfect conditions. Every decision is carefully thought out and discussed. Would it work on the second attempt? Perseverance's drill collected a core that was 6 centimeters long, and, possibly with wry exasperation, before sealing the core in a tube, Perseverance brought it round and added an additional step. It took a photo of what it held, to confirm to everyone on Earth that it was actually holding a core this time. Scientists must have felt a huge relief as data came back that Perseverance had successfully taken the core and transferred it to its storage area. The core, nicknamed Mont Denier, was ready to be taken back to Earth on a future mission where, in a larger lab, its secrets could be better analyzed. Perseverance took another core sample that day, just to be absolutely certain. They were possibly feeling on a bit of a roll, and who could blame them? They were now one step closer to knowing whether life ever existed on Mars. Although this sample was just the beginning, and may not have any signs of life in it, they had stepped a little further into the uncharted. A week or so went by. A first success was swiftly followed by a third and a fourth, both taken from the rock named Rochette in early September. The crater floor campaign was going well. At that point, sadly, it had to take a pause for solar conjunction. Due to the arrangement of our solar system, Mars and Earth do not always have a line of sight on each other. Sometimes they are on opposite sides of the solar system. This increases the lag time it takes for NASA to send and receive messages from Perseverance, but that is not the worst problem. When Mars and Earth are perfectly opposite each other, communication between the planets becomes completely impossible for one simple reason: the Sun. No radio signal can penetrate this cosmological giant. As such, there was little scientists could do but wait for these orbital bodies to move apart. Perseverance has advanced AI on board, but it still needs to check in with NASA from time to time to plan its route update its mission, and report back its findings. So it wasn't until November 2021 that things could really get going again. But NASA was not idle during this solar conjunction. By the time Perseverance was powered up again, the NASA scientists had already thoroughly worked out its next objective. In Jezero crater, there is a dune field known as Citar. In amongst these dunes, there is a series of outcroppings that were of particular interest to Perseverance's mission, due to the many different layers of exposed rock they gave access to. These different layers likely represented different geological eras, which would give scientists the clearest picture of the history of Jezero, as well as giving them an opportunity to find life itself. Outcroppings are of particular interest because Perseverance's drilling equipment only allows it to dig several centimeters deep. If it wasn't for outcroppings, where erosion had exposed these layers to the Martian atmosphere, Perseverance would not have access to them. However, sand dunes are of particular danger to a rover like Perseverance. With help an entire solar system away, if Perseverance was to start wheel spinning in a section of particularly loose dune, it would likely spell the end of its mission. As such, Perseverance's trusty sidekick Ingenuity was sent in to conduct some preliminary reconnaissance. If it could find a route through the sand dunes that looked safe, Perseverance could get its sample tubes to the vital outcroppings of Citar. Ingenuity began its scouting before the solar conjunction and flew for several flights from September through to December. Flying at a height of 10 meters, these reconnaissance expeditions allowed scientists to pick out the perfect route. Perseverance set off in early November 2021, beginning its exploration of the dunes. It picked its way carefully, being sure not to travel too fast in case it fell into any unforeseen sand trap. It moved between dunes that were a meter high, finding the flattest path. But thankfully, Ingenuity had led it true. Perseverance was able to make it to the protruding rock known as Brack. Now that it had its technique down, Perseverance quickly was able to obtain new samples. Deciding to call the first empty sample container at Brack an atmosphere sample, these next two samples were officially Perseverance's 5th and 6th sample tubes and their 3rd and 4th rock samples. From these accumulated samples, scientists were able to make an unexpected discovery. These were not sedimentary rocks, as had first been anticipated. Instead, Perseverance had discovered the igneous rock, olivine. Olivine is a type of mineral that can actually be found here on Earth, for instance in parts of Australia. Unlike sedimentary rocks, which are made by particles of sand and other detritus slowly accumulating on top of each other over time, an igneous rock like olivine is formed by the cooling of magma. As such, it seems that at one time or another, Jezero crater must have been witness to some volcanic activity. While this might initially seem to be bad news, you might correctly conclude that not much life could be found in magma, scientists could discern signs of water erosion on the rocks. The ridges at the ends of the crater showed signs of water motion. Whatever volcanic activity had happened here, the water that created Jezero's delta must have come after it had already cooled. As such, the presence of igneous rocks was actually good news. Igneous rock is usually very high in minerals. This is why the areas around volcanoes are so fertile. The presence of water and high mineral count rocks could have been the perfect conditions for life. All in all, Perseverance's mission seemed to be going well. But Mars was not done with it. The desert does not give up its prey quite so easily. On Wednesday the 29th of December, on the return journey out of Citar, Perseverance stopped to take another sample from another rock outcropping known as Isol, specifically from a small stone known as Rubion. Initially things seemed to go well. Perseverance cored its target rock with no issue. It placed its core in a test tube. But when it came to transferring the test tube into the bit carousel on the rover chassis, it hit an unexpected resistance. Something was blocking the tube from entering the carousel. Perseverance immediately stopped its process when it detected the anomaly and sent a request to NASA asking what it should do next. Through week-long exchanges, NASA was able to use Perseverance's cameras to peer inside the carousel. Staring back at them were 4 small pebbles. Now, this might not seem like a big deal, but pebbles that stop samples from being stored inside the rover would put a halt to Perseverance's entire sample collection mission. It was likely that these rocks had somehow fallen out of the tube during that specific sample collection, possibly once again because of the unexpectedly crumbly nature of Martian rocks. Rocks falling apart had already cost Perseverance 1 sample. Now they might spell the end of the whole mission. But the Perseverance team had a plan for situations like this, and carefully the rover began to enact it. Firstly, Perseverance started by taking photos of the ground below it. It wanted to see what was there already, so that once the pebbles were spilled out onto the floor, scientists could count the new arrivals and make sure that they matched up with what had previously been seen inside the carousel. Secondly, it did something it had never been designed to do. It emptied out its core sample tube onto the floor. It must have been with regret that this was done. However, it was important to know how much was left inside the tube to see how much was likely in the carousel. Also, this would allow a fresh ISOL sample to be taken later, maximizing its sample space efficiency. Thirdly, Perseverance began to do the only thing remaining it could do. It started to wiggle. By rotating its carousel, it was able to dislodge 2 of the 4 offending pebbles right then and there. By double-checking the floor afterwards, scientists were able to detect both pebbles, now no longer along for the ride. But this still left 2 pebbles remaining, and these were proving to be stubborn, not falling out with the carousel's rotation. So, Perseverance took things up a notch. It began driving away, searching for a spot where the slope was steeper. The plan was to position Perseverance at an angle, leaning forward so that gravity could start to pull on the last 2 pebbles. Its sturdy base meant that this could be done with relative safety, although tipping over would have been a disaster, so scientists would be careful not to pick a place that was too steep. A suitable location was just a short 5 meters away. Perseverance drove there and arrived at its location, only to make a surprising discovery. The other 2 rocks had vanished. Initially cautious and then elated, the NASA team deduced that the rumbling of Perseverance across the Citus sands had caused the rocks to shift and then fall out. They made sure to carefully test their equipment, making sure that the tubes could be correctly docked again. And only once everything was proven to be functional did they claim success. Perseverance was ready to go again. This may seem like a short drama, but my telling of the story might have been misleading. It was the 29th of December that Perseverance first picked up these stowaways. It was only on the 27th of January 2022, an entire month later, that the rocks were completely confirmed to be gone. This is because when you've spent millions of dollars getting a piece of hardware to another planet, care is always the watchword of the day. Although it sometimes takes weeks to plot out how to overcome a challenge, it's usually worth it for the longevity of the mission. Thanks to some careful decision making and moving correctly across the desert, Perseverance's mission could now continue. Having successfully collected its samples and overcome yet another challenge, it made its way out from among the sands. With Citus sands behind Perseverance, Perseverance's crater floor campaign was coming to a close. It would finally be time for the delta itself. If life ever existed in the now dry waters of Jezero, it was most likely the proof of it lay in those ancient river deposits, which was why it was time for Perseverance to really start booking it. The sands of Citus had forced Perseverance to travel with care, picking its route carefully to avoid getting trapped in any loose sand. However, the terrain outside Citus is much smoother. This allowed Perseverance to unleash its full potential. As it traveled up and around the outside of the dunes of Citus, Perseverance proved itself by setting the land speed record for a rover on Mars, 319.8 meters traveled in a single day. Admittedly, that does not sound very fast. The distance is only about the length of 3 football pitches, but this is impressive for a Mars rover. This was roughly 50% further in one day than the previous record of 220 meters set by the Opportunity rover in 2005. And bear in mind, it did all this by itself, choosing its route with its autonomous AI system, AutoNav. Being able to assess the terrain around it, on the fly and by itself, the fact it could pick out the best route to avoid obstacles and rough patches is incredible. And given that Perseverance's top speed is believed to be 120 meters per hour, Perseverance still has a lot of reserves to tap into. And Perseverance was not done there. It also completed the first multi-day drive on Mars, managing to keep driving without any input from Earth over a 3-day period. This has always proved challenging for rovers. Usually, human intervention is required, and regular updates are needed to help negate the uncertainty that always creeps into a rover's awareness of where it is. Without this intervention, it may get lost, possibly leading into dangerous areas. But Perseverance's AutoNav was able to circumvent this issue. Although some uncertainty does still creep in, Perseverance is able to keep track of its own location well enough that it can be left to run without these regular updates, potentially meaning it can be left to run over weekends or holidays without any supervision from Earth. This allows it to travel much faster and further, getting to the places where the best science can happen. Not that Perseverance wasn't doing science along the way to the Delta, it just did some of it autonomously too. Oh, and I think it's time we talked about Perseverance's heat ray, which it can use, you guessed it, autonomously. Yes, Perseverance has a heat ray, which it can decide for itself when to deploy. I've mentioned this laser earlier when I spoke about Perseverance's supercam. What I did not mention was that this laser didn't just point to interesting targets, it vaporizes them. When I first heard about this, I began to suspect that whoever designed Perseverance had read War of the Worlds and wanted to circumvent any possible invasion of Earth by getting the first hit in. And while this isn't likely the case, Perseverance's laser is no joke. It can heat rocks to a temperature of 10,000 degrees Celsius, melting them to plasma and vaporizing them. Before you ask, this incredible tool is designed for use in evaluating the chemical composition of rocks, not vaporizing aliens. By heating rocks up to such a temperature, the light they start to emit can be evaluated to see which chemical markers it carries. Different elements and compounds release light at different wavelengths. By seeing what light a rock emits or doesn't emit when superheated can be key in identifying its chemical composition for some on-site scientific analysis. Also, it should be noted that this is done on a very, very tiny scale. On the 11th of March 2022, Perseverance zapped one fascinatingly purple-colored rock a total of 150 times in the same spot, vaporizing its outer layers to see what lay behind the surface. However, all these repeated vaporizations only bored a hole into the rock that was a single millimeter deep, hardly a weapon for fighting Martians. But these are the tools Perseverance employs as it continues its journey, working with scientists along the way to abrade and laser various samples for a little en route science. It even accidentally picked up a pet rock along the way in one of its wheels. This small stone was deemed not to hinder the rover's movements in any way, so scientists have left it be. So far, the rock has accompanied Perseverance over a distance of 8.5 kilometers over the course of 4 months, and has proved to be far less of a danger to its mission than the last rocks that it accidentally acquired. But with the arrival of one friend, another would begin to depart. Technology, although impressive, is not infallible. On the 3rd of May 2022, as Perseverance was reaching the end of its journey towards Yezero's Delta, communications dropped out with Ingenuity. The Ingenuity helicopter had accompanied Perseverance since the beginning of its journey, the two machines traveling together to the Red Planet and helping each other perform their different missions. Ingenuity had already amazed the world by being the first flying machine on Mars. It had scouted out the route for Perseverance during most of its mission, spotting hazards in advance so Perseverance could avoid them. But Ingenuity's intended lifespan of 30 days was already long past. Every day the helicopter still functioned was a gift, and one that could not keep giving forever. When Ingenuity first started off on its routine flight, Perseverance thought nothing of it. The two machines weren't always in line of sight with each other, instead keeping contact with frequent radio check-ins. However, when the next scheduled call should have come along, Ingenuity failed to check in. Perseverance froze in its tracks. Scientists thought desperately about what might have happened to the small helicopter. They theorized that if some kind of fault had occurred on Ingenuity, it was possible that it had gone into a safe, low-powered mode to preserve itself, thus missing its communications window, or possibly desyncing its onboard clock from Perseverance's. As such, Perseverance waited a full day, listening all the while to see if Ingenuity would wake up and start communications again. And thankfully, it did. The little helicopter was alright, reporting no major faults. However, its silence had been extremely worrying. It turned out that the problem was the levels of dust in Mars's air. Over time, Ingenuity's solar panels that kept its battery topped up had received less and less sunlight, causing the batteries to dip dangerously low. It had entered safety mode to keep itself from losing the heaters that kept it from freezing to death in the cold Martian nights. Ingenuity was given several days of lessened work to give its batteries more time to charge up to operational levels. However, this came at a cost. It would use its heaters less from here on. Instead of turning its heaters on when temperatures reached -15 degrees Celsius, Ingenuity would only turn them on at -40 degrees Celsius. And nights on Mars were about to get colder. Eventually, that cold will prove to be too much. Wearily, Perseverance and Ingenuity continued on, but now their goal was in sight. The sands of the Jezero crater floor were behind them. They had finally entered the delta. With that, a whole new campaign would begin. Perseverance had done so much in the first year and a half of its time on Mars. It had performed science, traveled through dunes, and overcome challenges through careful problem solving. But did it already succeed in finding life? Ultimately, we will only truly know for sure when those samples return to Earth. Once that happens, it will hopefully be clear how influential the crater floor campaign has been. Even if it finds nothing, that in itself will hint at an answer. But for me, it's much more tantalizing to imagine that even now, the irrefutable answer to whether life once flourished on Mars might lie in a little transparent cache safely nestled inside Perseverance's casing. It might be in the next decade we find out that answer. But until then, Perseverance will remain true to its namesake and will keep on going with its mission. All war is deception, said the ancient Chinese tactician Sun Tzu. And so perhaps it's unsurprising that the planet Mars, titled after the god of war, is quite the deceiver. Optical illusions and trickery have been part of Mars's story since the 1800s, when astronomer Giovanni Schiaparelli first looked through his telescope and saw canals crisscrossing the planet's surface, hinting at advanced alien life. The only problem? No such canals existed. They were phantasms, an apparition. Sometimes, trusting your own eyes is a dangerous thing. The Perseverance rover in our own time has its work cut out for it. It's a successor of Schiaparelli, continuing the hunt for signs of life on Mars, except this time it travels across the surface of the planet itself. And certainly, it succeeded. It has photographed images of advanced technology on Mars, but the Red Planet has a long history of deceiving us, and not everything is what it appears to be. What is the trick, and what is the reality? I'm Alex McColgan, and you're watching Astrum. Join with me today as we look at some of the strange objects Perseverance has imaged on the Red Planet that caused us to make sure our eyes weren't playing tricks on us, in the 6th video in this series on this incredible rover, covering May 2022 to September of that same year. Perseverance had entered an exciting time in its journey in May. Its mission had finally taken it to the Jezero crater delta, the location scientists were the most optimistic about finding signs of ancient alien microbial life. hopefully buried in layers of ancient silt and clay from a massive dried out river. A discovery of even rudimentary life in such a place would be mind-blowing. It would completely revolutionize our understanding of our place in the universe and would vastly increase the probability that we are not alone. Discovering organisms that were more advanced than bacteria would be orders of magnitude more earth-shattering, particularly if we found something intelligent, as Schiaparelli once thought he discovered. And so, Perseverance attempted to collect cores and photograph abrasions from locations such as Enchanted Lake, Three Forks, and Hawksbill Gap. It didn't have an easy time of it initially. Many of the rocks it encountered, such as the ones in the Devil's Tanyard area, proved to be extremely crumbly and broke under the force of Perseverance's abrasion drill, or had surfaces that were too rough to even begin the attempt. It wasn't until July that Perseverance was able to successfully take its first core sample from the delta, from a rock named Skinner Ridge. But in the next few months, as it traveled from location to location, it began to image things from a distance that looked decidedly out of place. Namely, in September, it spotted a cat. This was not a real cat, of course, but simply a somewhat cat-shaped rock formation. In my opinion, it's quite the rough comparison, but many people were amused by this feline fake-out loafing in the Martian sun, with the image making the rounds on different media outlets at the time. I was more impressed at the image of the snakehead that Perseverance captured earlier in June. You can almost see the creature's eye here, as it tastes the thin Martian atmosphere, perhaps looking for a treat to eat. Like a snake on the hunt, or perhaps a lurking moray eel. Such illusions are easy enough to recognize as illusions. I don't think anyone truly believes that there are snakes or cats lurking in Mars's arid deserts. But moments like this have an important connection to another rock formation scientists found on Mars back in 1976, when the line between illusion and groundbreaking discovery became a lot more blurred. It's one thing to find a rock outcropping that sort of looks like a cat. It's another thing when your orbiter takes a photo of a 2-kilometer long image that looks perfectly like a human face, right there on the Martian surface. What do you think when you see this image? Maybe this is something someone made on Photoshop? But the crazy thing is, this image is absolutely real, and was taken by the Viking 1 orbiter nearly 5 decades ago. It was released to the public by NASA, and naturally set theorists ablaze with speculation as to its origins. Could something that seemed to mirror our own features so perfectly really be a naturally forming coincidence? If not, who had built it? A long-lost civilization that perished on Mars millennia ago? An alien race that later traveled to Earth and became our ancestors? Theories abounded. So much so that NASA scientists felt it important to go back to the area and image the location a second time. They did so in 1998, and again in 2001 with the Mars Global Surveyor. We now have high-rise images of the location. Thanks to the much better cameras available on these newer orbiters, the true dimensions of the face on Mars could be mapped out much more clearly. What was revealed was less distinctive than the original shadowed image. While it's still technically possible that the face on Mars was once much more distinctive, but has simply had its features smoothed down by weathering, it seems more likely that we can chalk this one up to a human tendency known as pareidolia. Pareidolia is the habit we have of seeing recognizable images in actually quite random visual patterns. For instance, have you ever looked at a cloud and spotted something that looked recognizable? A person, or an animal, or a car? Pareidolia has been with us since ancient times. It is thought to be an evolutionary trait. If there's some lurking predator hiding in the undergrowth, being able to identify it as such with only a few visual cues is extremely useful. The downside of this is that sometimes we see meaning where there honestly is none. A man out of the corner of our eye, but there's no one there when we turn. a message in our cereal bowl, a face on Mars. Our minds are never unbiased and are constantly interpreting the visual stimuli we take in, trying to piece the world together in a way that makes sense. This can be a great aid to us, helping us identify important patterns in data. However, we have to be very careful with it, as it can also be a hindrance if it ever leads us to jump to conclusions that later turn out to be untrue. Sadly, when it comes to Mars, not all illusions are based on untruth. Perseverance's next discovery is 100% factually accurate. Back in April 2022, Perseverance started imaging strangely bright-colored objects in the Delta's distant terrain as it passed by. These objects were something of an enigma. Scientists weren't sure what they were, only that they were perhaps roughly 15 centimeters in size. They named the bright material, and called it a day. Hopefully Perseverance would be able to get a closer look later. Later arrived in June, when Perseverance finally imaged something. It was definitely not a rock formation. It was silvery in color, very thin, with a routine pattern across its surface. It was clearly artificial in nature. And it wasn't alone. Within the next few months, Perseverance also imaged a tangled ball of string, and even some netting. 6 such pieces were recorded in the area, with these the creation of a race of technologically advanced entities thousands of years old. Yes, but sadly, just not an alien race. They were from us. Scientists were quickly able to identify all of these objects as either being part of the entry, descent, and landing system, or the sky crane that had lowered Perseverance onto the planet all the way back in February 2021. The silver material was a thermal blanket and had been part of the spacecraft that had brought Perseverance down through the atmosphere of Mars. The string and netting were likely Dacron netting, which was also part of the spacecraft and sky crane's insulation. Both sets of material had clearly been torn apart by strong forces. There's a curious facet to this, however. It was a little surprising to find these materials here. Perseverance's landing was roughly 2.5 kilometers to the southeast of this location. Sky Crane had presumably landed somewhere nearby. And while the parachute and parts of the spaceship had come away earlier, and so had landed at a more distant site, these had already been found. Ingenuity had taken photos of the downed parachute and parts of the spacecraft roughly 1 kilometer northwest of the landing site. That still left approximately 1.5 kilometers of additional distance the material had to travel. In the end, the solution to this question was simple. The wind was to blame. Over the 1.5 years that Perseverance had been traveling around the planet, taking samples and abrading rocks, the shifting Martian wind had taken debris from the crash site of Perseverance's spacecraft and had slowly but surely been migrating it across the planet. It is a testament to the relentless nature of Mars's winds and the fact that there is no one on Mars doing litter collection. This discovery was a splash of cold reality on Perseverance's mission. While this mystery was solved, it suddenly meant that there was a chance, however small, that cross-contamination was going to be an issue going forward. If debris was traveling across the planet in the direction Perseverance was heading in, then there was a chance that if that debris carried a small, hardy bacteria that had somehow survived the trip from Earth, it might throw off the results. Fortunately, such a chance was reassuringly small. Not only did NASA work hard to keep Perseverance free from contamination during construction, making use of clean rooms to keep bacteria and dust out, even if something from Earth did find its way into a sample tube, scientists would likely be able to recognize it as such. Still, scientists would be careful going forward of contamination or of getting debris stuck in the rover's parts. Perseverance's mission goes on. In its effort to uncover the truth, it will have to uncover the tiniest of details. However, what I've come to realize is that one of the biggest hurdles it must overcome is us. it is almost impossible to completely remove bias from ourselves, and yet biases can cause us to interpret data in such a way as to allow ourselves to be fooled by tricks and illusions. Although NASA was quick to recognize the artificial materials as their own, it would have been easy for someone with less rigor to try to connect such discovery to alien technology. After all, the temptation is surely there. The person who proved alien life existed would forever go down in the history books. But without taking time to double check that what we want to see isn't clouding what we are seeing, we might go down in history for a very different reason. Nobody wants to be famous for being the person who saw aliens when they were only rocks and debris in a crater, after all. Thanks for watching. I really want to give a huge thank you to our astronauts on Patreon. It's really becoming a thriving community, and I've loved reading all your messages and comments over there. If you'd like to join in, then you can visit the link in the description to become an astronaut and bring the channel more stability than the algorithm. When you join, you'll be able to watch the whole video ad-free, see your name in the credits, and submit questions to our team. Once again, a huge thank you from myself and the whole Astrum team. Meanwhile, click the link to this playlist for more Astrum content. I'll see you next time.